Very good morning, participants. Participants, good morning.
Good morning, sir.
Good morning, sir.
Good morning,
Thank
sir.
you. Thank you, sir. And welcome back to the second day of the FDP. And today's morning session is about interfacing sensors with Arduino. And the resource person is Professor Dr. Sabith Ramakrishnan from MIT, Chennai, Anna University. A brief profile about her. Dr. Sabith Ramakrishnan is an associate professor in the Department of Instrumentation Engineering, MIT campus, Anna University. She is also the Deputy Director of Internal Quality Assurance Cell, Anna University. She obtained her BE-ECE from College of Engineering, Guindy, Anna University, with gold medal for academic proficiency. ME Electronics from MIT campus, Anna University, and PhD in Wireless Sensor Network from Anna University. She has more than 20 years of experience in teaching and R&D. She has also served as the coordinator of entrepreneurship and development cell and the associate placement officer in the erstwhile employment. She was the organizing secretary for the international conference TIMA 2017 in MIT Anna University. Dr. Sabith was adjudged as the best outgoing student in her diploma program in Government Women's Polytechnic, Chennai. She also received National Merit Scholarship Scheme certificate in her SSLC. She received the IEEE Appreciation Award from Chairman IEEE Madras Section for arranging and delivering technical lectures as IEEE Executive Committee member during 2013-14. She received Dr. APJ Abdul Kalam Award for Teaching Excellence from Marina Labs R&D in 2016 and Best Quality Assurance Cell Coordinator Award from SEED India during National 4th Edition Summit in October 2017. As a researcher, she has published 10 papers in international journals and 16 papers in international national conference proceedings. She received the Best Paper Award twice in 2 international conferences held in 2014 and 17. She has completed 2 R&D projects so far, one AICTE RPS project on ad hoc networks worth Rs 12 lakhs in 2009 and a DST funded project worth Rs 32 lakhs in 2018. She received the Best Innovation Award from CTDT Anna University in 2021 for the automated external defibrillator prototype developed in the project with several unique features. She was one of the principal investigators in the UGC project of Anna University worth Rs 75 crores under the prestigious recognition of the institution as University with Potential for Excellence in Biomedical Instrumentation. She has jointly filed 2 patents for the IP developed in the DST project and the UGC project. She received the Best Mentor Award from CTDT Anna University in 2014 for guiding a student innovative project on wearable sensors. She is a reviewer for international journals including Springer, InterScience, and elsewhere. She has chaired several technical sessions in international national conferences. She is a member of Board of Studies for 2 colleges and 1 polytechnic. As a faculty member of Instrumentation Engineering MIT, she has augmented the electronics lab facilities by securing special grants worth Rs 2 crores in the past 10 years. She has organized around 25 training programs so far, delivered around 35 guest lectures in various institutions on topics including WSN, signal processing, and embedded systems. She has made official visits to Germany and Qatar. She is a member of IEEE, IETE, and ISTE. And we are fortunate to have ma'am with us for the today's session on interfacing sensors with Arduino. And we welcome Dr. Sabith Ramakrishnan for the session and the handover session to ma'am. Ma'am, please.
Thank you. Thank you so much for those kind words, Dr. Sendila Rasu. And it's really a pleasure for me to address faculty members of Polytechnic because basically I am a diploma holder from Government Women's Polytechnic, Tharmani. Am I audible? Am I audible?
Yes, ma'am. From all engineering colleges, mostly from engineering colleges, ma'am.
Faculty members are from engineering colleges also. Okay.
Engineering colleges.
Yeah, that's fine. Yeah. So I'm a diploma holder and I turned into an engineering graduate. I did my part-time. So I have an affinity towards polytechnics, definitely, because polytechnics are very targeted towards the outcomes in terms of hardware and the results, etc. And even the education is very, very pinpointed and to the point, I would say. So not beating around the bush. I'm not undermining the engineering education, because the design aspect is definitely there, and our students should contribute towards the design aspect, not simply replacing parts and components when it comes to repair or servicing. So let us just jump into the topic, interfacing sensors with Arduino. Now, what I'm going to present today, I would like to, oh, it's not moving at all. Yes, okay, it's a little slow, I think. Okay. So, I would like to brief you about how I'm going to present. For about 1.5 hours, I will be making this presentation. After which I want to leave half an hour slot to my student who has completed her graduation under in our department, and she did her project under my guidance. And incidentally, her project work we published as a paper in a very reputed journal, InterScience Publishers, very recently. And it was on IoT application, and she did initially with Arduino boards and later with Raspberry Pi boards, and she has a combination of both also. So it's a wireless sensor network. My specialization is basically in wireless sensor networks, and I moved into biomedical signal processing and prototype development because of the projects that we took up. Okay, and this is the overview of the presentation. So my student, Ms. Baba Tarangini, will just present for the last half an hour with a short demo video of the project that she has done. But I would be presenting most of the information that I am presenting here, apart from the theory part, is part of the projects that we have run here as UG, PG, and PhD work that we have been doing. And all those things only I'm going to present. So many of you might have already worked with Arduino, or you may be familiar with Arduino, and many of you might not have even opened the chapter of Arduino so far. So, so it's always difficult, right? For all of us teachers, we have to address a very heterogeneous group where people will come with different backgrounds and different backup knowledge. So, I'm just addressing with regard to the topic per se. Okay, I'm not going to question your, backup knowledge or your expertise. So if I start that, then I may not be able to proceed further. So I may have to curtail my presentation or something. So let us go about, even if it is a repetition of what you have already heard or going to hear, just pardon us, because we are all speakers from different places and we don't interact with one another. We present in accordance with the topic given to us. So it is always better, no? Hearing twice or thrice about the same topic is always better also. Right. Now let us just look at the topics that we are going to cover today. We will just take up the Arduino fundamentals very briefly, and then the typical sample program that is always given along with Arduino, which people definitely use, and I always advise my students to do this before they start using the Arduino board. They have to use this program, because we buy Arduino boards from, we order in online, and then we get it and we start working with it. It may finally happen in such a way that your programs are good, everything is good, your cable is good, but the Arduino board is not working, or at least that port is not working. So all this happen. You must remember that in Arduino, all the ports may not work all the time. We have had this difficulty earlier. So it is always better to check before we start using any board. So always run this sample program before you build your own programs, right? Then comes the interfacing of sensors with Arduino, the topic of the day, topic of my lecture. And I'm not going to stop there, because even this you might have heard from many other people. Now I would like to discuss how we are making a wireless node by interfacing not only sensors, but also by interfacing some RF transceivers. When you interface RF transceiver, it is now going to act as a communicator. The board, Arduino board, will do the processing, and the sensor will do the sensing. So the sensed data can be processed by the Arduino board, and it can be transmitted using the RF module. And it can, the same type of node can be designed for the receiver part, and you can put it in receiving mode and you can start receiving the data. So this will establish a wireless communication of the sensor data itself. Now, so since that may be more interesting, I thought of talking about interfacing of sensors and also interfacing of RF module, so that we can make a wireless node. And okay, we don't stop there. We can make a remote healthcare monitoring application by choosing biomedical signals, and then we can build a soft network where we can send the biomedical data, transmit it, receive it, and then do some processing. Don't stop. I think somebody has unmuted, so I'll find out who it is. Yeah, they are muted. Okay, thanks. So what we are going to do is first interface the sensor so that it becomes a sensing board. Interface an RF module so that it becomes a wireless node, and form 2 or more such nodes, and then network them together so that it becomes a healthcare monitoring system. And then we also develop an IoT application where we can post the sensed data into the website. Free websites are available, plenty, like 30 to 50 websites are available. We will just choose one of that, and then we will upload it in that free website. Now, I'm not sure whether you are able to see the screen fully, because this is also coming. This, I don't know how to push all these things. Even if I push down, it is not moving inside. And this yellow color, I don't know how many of you are seeing a yellow patch here. Are you seeing an yellow patch here?
Yes, madam.
How to remove that? I'm not able to remove that. It's not moving here and there. It's just there. Okay, we have to live with that, I think. Anyway, let it be part of the presentation. Or shall I try to present the screen desktop itself?
Ma'am, you can remove it from PowerPoint master slide. From the PowerPoint master slide, you can
Master
remove
slide
it.
doesn't have anything.
Yeah.
Master slide doesn't have anything. Okay. So this is part of the Zoom. Minimize this ribbon. See, this is not part of the slides, okay? It is part of the...
You can move that away, ma'am, on the corner. You can move it away to any corner.
Yeah, it's not moving actually. It's not moving. Okay, anyway, this is a new experience for me in Zoom, because we normally use, see, this is coming, but I'm not able to move this window away. I'm not able to move. Maybe as an organizer, you can try doing, I don't know, but my screen is being shared. This is only pertaining to the slide PowerPoint presentation. So this remains here. Okay, let us not waste time too much on it. Let us forget about that. Okay, so just bear with it. Now, regarding Arduino fundamentals, I want see, all these things are available in the website. We are only doing a compilation and presenting it to you. But what is the value addition that we can make is, from our experience, we can tell you certain things or certain hurdles that we face when we are using the codes for interfacing. Now, one thing is, okay, let me just finish this topic. Like, it is an open source electronic prototyping board. Now, there are many terms here. Like, it is open source, meaning they don't charge you. There is no copyright violation that will happen if you use this. And it is an electronic prototyping board. So that means, do you have any other prototyping? Yes, we have mechanical prototyping. We have electric prototyping. We have got some hybrid prototyping boards. Boards illa systems. I can quote an example. 3D printer is a mechanical prototyping platform. Okay, where you can make your own components with your own material, etc. So it is electronic. And what do you mean by prototyping? Prototype. Abdina enna? Anybody can answer. You can unmute and answer. New to Arduino. Okay. Somebody says they are new to Arduino. Okay.
Prototype means set of rules, man.
That is protocol. Protocol is a set.
Protocol is.
Yeah. Protocol means a set of rules which we follow. Like what protocol are we following in our communication today? We are all okay with English communication. So English language is a protocol for our discussion today. Let us say like that. Correct. So there's a set of rules that we follow in order to establish some useful operation or useful process. That is protocol. But what about prototyping? So have you heard about this prototype? Something a word, what is the meaning of prototype? Anybody? Somebody is on the design template. Yeah, we can say so, but it need not be a design template. A prototype is normally a functional dummy model. No. It's not a dummy model, Swati, and it is not a design template alone, Samujal. I hope I'm pronouncing your name right. Now, what I would say is, yes, it is functional. Satyapriya is right. So it's a functional model. That means it's not a model. It is actually typically like a device, the end device itself, but it is a prototype. Say, for example, you are soldering and you are using breadboard, and then you are achieving some timer. Okay, some timer operation or something using a multivibrator circuit, op-amp. Okay. So you can assemble a timer. Now, yeah, somebody is Googling and answering. Yeah, Sanjay Prasad has taken it from Google, I believe. Okay, so that's okay, fine. Now, it's a process that you follow to achieve the functionality success in functionality. It need not be like a product. Okay, like an aesthetically nice or ergonomically feasible, nothing like that. It is functional, that's all. So that means it gives you a confidence that you can move on to the next level of developing the product, commercial product. So such a thing is called a prototype, and prototypes are the ones that you develop as the first step towards any design. So you make the design procedures, you develop the prototype, test it, and you may have some success, partial success, or full success, and then you move on to commercial product design. And when it is a commercial product, we will think about compactness, weight, energy efficiency, and appearance, everything. But all these things need not be there in prototype. So prototype functionality when you're testing, it is always better to use prototyping boards. Now, there is another name for prototyping board. Can you say what it is? Can you just guess what is another name for prototyping boards? Anybody? Quickly. They are also called something. Yes?
The development board.
Exactly. Exactly. Yeah, you are right. Development board. It's called development board because you develop an application or you develop your own functionality using a platform. Prototyping boards are also called platforms. Now, another word here is platform. What do you mean by platform? A platform is a generic base that you have, okay, on which you can build. Let us say the Play-Doh or this plastic parts, the toys that people make. Now, what is it called? From plastic pieces, they make build structures. So we can call it as a platform because they build whatever structure they want. The children build whatever structures they want. So platforms are a generic base over which you develop an application. Remember, platforms can be hardware or software platforms are also there. Okay, many of the RTOS platforms are software platforms where you can build your own application using the software platforms. Okay, like the embedded system platforms are there, software plus hardware together. So they are called hybrid platforms. Okay. Now the Arduino board is a cross-platform, means it can work on several operating systems comfortably, Windows, Mac, or Linux, and it is simple and accessible. Means it is it doesn't involve complex programming procedures, because the reason is it has got inbuilt libraries. Okay, so we can easily program it, and it is inexpensive. Can you guess the cost of Arduino board? Should I check the chat, or somebody can answer also? Just tell the cost of Arduino board. But Google pannakodadu. If I'm getting the answer after 1 minute, it is only
Ma'am,
Google answer.
approximately 350 rupees.
Yes, 350, 400, 500. Why is it varying? I also have Arduino boards for 5,000 rupees. So then what is the difference between an Arduino board that costs around 500 rupees and an Arduino board that costs around 5,000 rupees? As an engineer, as a design person, you should know the reason behind the costing. So that is another aspect. You please note down, and you also make your students to do that. I can tell you some more aspects when I come to that, those details. So definitely we all know, we can tell with eyes closed that yes, the complexity will be high, the number of I/O ports will be larger, the memory will be more, and the programming memory as well as the data memory, all these things will be more, and inbuilt sensors, onboard sensors, and onboard facilities will also be there, etc. All these things we all know. Why we should we necessarily buy that high cost board, or can we do the job with low cost? That depends on your application. Okay, my professor used to say, if you want to destroy the ants, red ants, what will you use? You will only use 1 spoon of kerosene, or you will simply put one cloth with fire in it so that it also burns, or you simply put something and you will strike it, or pour some phenyl. Will you drop a nuclear bomb on a molehill or an anthill? No. Right? So use the right tool for the right application. If the application requires only the simple Arduino board, you have to use only that. You should not buy 5,000 rupees board just because your budget allows that. You should use only the right board. I'll tell you why you should not use later. Okay, remind me if I'm not telling. So it all depends on the number of digital IOs and the analog IOs that you have. Now, what is PWM? We all know that. Okay, I'm not going to ask you such silly questions. So PWM output, pulse width modulation outputs, are basically analog outputs. Although the digital data is coming out, the digital voltages can be converted to analog using pulse width modulation. So that is why we have analog outputs that are given to basically the DC motor, the any motor control, we can use PWM output. Okay. And then the voltage, input voltage is also flexible. That's also one advantage. You can have a range of voltage. Depending on that, it will operate comfortably. So there's no strict tolerance on the supply voltage. And the transmit and receive pins are there for serial communication, which is effectively utilized for programming, because the USB cable can be used for programming, and we can also use the board for transmitting the data. The IO data can also be transmitted over the cable to any device that is connected. Okay, and that can be an RF module also. And it has got a programmable circuit. Now, interestingly, what is IDE? I heard that there is another person who is going to take a session on IDE. What is IDE? It is, let me know.
Environment. Integrated development environment.
Integrated development environment, which is basically allowing us to develop the code by ourselves, test the code before we upload it into the board. Now there are two versions, like some boards they say download into the board. In some boards they say upload into the board. Just forget about that. You load it. That's all. You load the program into the board's flash memory and it starts working. So this can be done from the PC using this IDE, so that you comfortably work in the simulation environment, check the syntax, check everything, and in simulation, and then you convert it into the downloadable files or uploadable files. We call them as hex files, and these hex files can be directly written into the flash memory of the board. Now I have yes. Okay. There are several Arduino types. As I told you, there are Arduino Uno, which are cheaper, Arduino Mega, which are expensive. Now, this is what I wanted to tell you. Now, depending on the memory, program memory, you can write bigger programs if your requirement, if your application needs a lot of controls, a lot of IOs, and a lot of processing, then you can use higher program memory boards. Like that, it goes on. Okay. So I cannot elaborate on each and every topic, although I can, but I should not because of the time constraint. So this is why you have various courses. Now, one small thing I want to tell, although I'll not dwell into all these things. When we used the Arduino board, we used the Atmega 328 based board, okay, and there was Atmega 1 to some number, okay, that was also available. Now, we thought, okay, better, higher, sophisticated, more sophisticated, the better. But when we did some energy analysis, we saw that the clock, I think the clock is not given here. Okay, the clock speed was high for this Atmega 328 based boards that we developed, rather than Atmega, that earlier version. Now, because of the high clock, the higher frequency of the clock, the power consumption was higher. While we did not require that much high clock rate at all. So, even clock speed, if it is a simple application, you should choose only a smaller board with a simple Atmega controller. Whatever microcontroller they are using, you should choose only the smaller version so that the clock speed is low and hence your energy consumption is also low. You must understand as design engineers in digital world that higher the clock rate, higher the power consumption, because the clock will keep coming, the clock will keep consuming the current. Okay. And how much you know? It was like 10 times the current. So energy analysis was not up to the mark because it was consuming too much current. So we are now talking about the Arduino Uno board, which was of primary interest to us. Okay, I'll tell you what. Although I don't have it here, we developed our own processing board and we stopped using the Arduino board. The Arduino board was costing around 500 rupees to 1000 rupees. Arduino Uno costs around 750, I think. I don't know about the latest cost. Online cost also varies. We wanted to make use of the programmed microcontroller in our own board. So we will program using the Arduino board. We will take this IC and place it in our PCB. So the programmed microcontroller will start functioning. All we have to do is connect a clock, connect the sensor, and connect the battery or power supply. Okay, external power supply also you can connect. And then the sensors we have to connect and the RF module. That is enough. Even USB is not required because programming is done from the PC and the wireless node can be used with its RF module separately. So with all that put together, our entire wireless module cost came to only around 600 rupees with the PCB lighting and all that, PCB board design and all. So it is such a simple thing that you can do, and this has got removable IC, removable microcontroller. But in some mega boards and other boards, no, you don't have that removable microcontroller, and you cannot make your own board after programming. In Arduino, you cannot make your own processor board. So that is why we preferred using this Arduino board. Okay, and you see here 16 megahertz clock speed. Do you really require 16 megahertz clock speed for simple temperature environmental monitoring? No, not at all. You will be doing it only 1 minute, once a minute, or once in half a minute. So So even that will not be there. It's no use having such high clock speed. So we can do it with some kilohertz of clock speed itself, if it is still there. So we can buy such microcontrollers and we can program them separately. We need not even use Arduino boards. Okay. Right. So I'm just showing you these configurations to just tell that there are some say analog reference pin, digital ground, digital IO pins. So many digital IO pins are there, which will help us to interface a number of digital IOs. Okay, external digital IOs we can. Now this is the transmit and receive pin, which we can effectively utilize for interfacing our wireless modules and other things, the transceivers, etc. Or we can connect the cable and use it for some other device. So USB cable can be used for PC interfacing, and serial in and out can be used for interfacing some other communication module. And you have reset button, you have in-circuit serial programmer for selecting and programming, and you have the microcontroller, which is the heart of the board, and then you have the analog input pins. Okay, so the analog inputs, and it has got an inbuilt ADC, and it can convert. We can set the clock rate also. We can set the sampling rate also. In deeper programmings, we can do that. And you have the reset pin, the voltage power pin. Now 5 volt is there. I'm not able to show you this. 5 volt is there and 3.3 volt is there. Do you know why? Some of the add-on modules that are working based on some power supply that is given by this board, they may require different power supplies. So our board RF module that I'm talking about, it works on 3.3 volt. Okay, we can use this power pin for powering that RF transceiver module, and 5 volt for any other purpose we can use it. And power input you have to give. Okay, and you also have power. See, there are two things. One is the powering of the Arduino board that can be done by using the USB cable itself, or you can give external power using the power lines, and you can use the Arduino board to power some other modules also. So all these are possible. And you can use the PC to power it, or external power supply, the 5 volt power supply to power the board. Now there is a variant that is called Arduino, which is having some onboard sensors apart from the regular features like the LDR sensors, and I2C jumpers are available for serial communication. So serial communication, several types are there. I2C is also used for in instrumentation. I2C is mostly preferred because of its current output. And IR receiver, this IR transmitter and IR receiver can be used. This is onboard sensor, okay, the IR sensor, and LDR, light dependent resistor. This sensor is there. So some onboard sensors and other serial communications are already available in these modes. So we can use Arduino, whatever you want, you can use. Now these are the pinouts. I'm not going to discuss in detail regarding the pins, but we need these pinouts properly for any IC that we are buying. Now, one interesting experience I would like to share is we bought one IC called instrumentation amplifier. Okay, we bought it and then we brought it to the department. Then we started searching for that IC's details, pin details and other things. We couldn't find. So probably it was from China, and Chinese they have not provided the data sheet for that. So they have simply bought those components from China without even looking at what instrumentation amplifier it is. So it was some number for which we didn't know. It was like having a Japanese person who is going to teach us some subject like that. Okay, we don't know Japanese, assuming that we don't know Japanese, like that. So the person with potential is there, but we cannot derive any information from them because we don't know the language. Like that, the IC was there, but we couldn't use it because we didn't have the pinouts and other stuff. So always remember to buy the data sheet. The same thing happened for the RF module also. We bought one RF module that was called RF24A. That's all, RF24A. And so along with that instrumentation amplifier IC, we bought this. There is no command sheet, configuration sheet, no spec data sheet, nothing. So once again, that was also wasted. So then we decided that we will not buy the components first. We will only go through the details online. And then if it is available, we buy online. Otherwise, we make a note of it and then buy only those components. Now, when you use the Arduino integrated development environment, it's basically a package, a software package that provides all the facilities for the programmers to develop the application that we want on a step-by-step basis in a very user-friendly manner. Okay. Now, first of all, we will have a source code editor, okay, and then we will compile it and then build the project, and then we'll use a debugger for removing all the errors, and then we will upload it into the board. So these are the steps that we will follow, and this call it as a sketch. Okay, sketch files or some things that we write, and these are specific names that are used by different vendors. Okay, the Arduino vendors prefer using sketches. Okay, so the programs are saved in the form of sketch in the case of Arduino. Now, basically, we will install the Arduino software from this website. Okay, and once you install this Arduino software platform will look like this, and they also give you a starting like speech. Okay, they are giving the in writing. Okay, setup is for running the setup code for initial configurations. What are the header files that you are choosing? Otherline the code. Next, do whatever you want to run repeatedly in a continuous manner. Repeatedly, it will keep running. So whatever you want to run in real time continuously, put that code here. And that running in loop, you have to ensure that you are going to give the condition for that running. So this is the sample program I told you that we generally ask the students to run before commencing their projects. This is for LED blinking. Okay. Now, LED blinking means we are now defining the pin numbers for the LED on and LED off by just declaring some integers. And then in the setup mode, we start the serial communication port with a given baud rate, 9600 baud. Now, my question, let me open the chat. So what is baud rate and bit rate? Satish Kumar, I'm a Tamilian, okay? It's only a small comment I give in Tamil. Just forgive us for that small usage. I'm sure that you will understand 99% of my speech. We speak only English. Don't worry. This Tamil language will be only a small tuition for you so that you can use it later. Okay. Now, what is the difference between baud rate and bit rate? Quickly. I can't wait for long. I have very, very limited time. Number of bits transferred per second is bit rate. Okay, Pumani, you are very straightforward. I understand. Bit rate is bits per second. Ana enak vendiyadhu baud rate. I want baud rate. Neeta, reciprocal. What do you mean? Bit rate is reciprocal of baud rate? No. No. Baud, the reason behind baud, I really don't know, but I can tell you the meaning alone. Don't Google. Okay. As the difference between passengers and a car with passenger. I really don't understand what you mean by that. Number of data frames per second. No. Okay, let me tell you. See, baud rate basically means symbol rate. Now, I suppose most of you or all of you would have studied the basic communication engineering and basic digital modulation principles. We have something called QPSK. Do you know what is QPSK and BPSK? Anybody from electronics background? I can find out from the chat box itself. No, it's not the channel width. We don't say channel width. Although say channel width bandwidth solana. Okay, Humani, you can say bandwidth. Bandwidth is also spoken in terms of bitrate. Bitrate and bandwidth are most often used interchangeably because the number of bits you transfer per second should be accommodated by the channel. So the bandwidth. Yes, QPSK is quadrature phase shift keying. Lavanya, you're right. Now the point is when you are transmitting in QPSK. Okay, let us. Yes, Rajeshwari, you're also right. So the BPSK and QPSK, if you are comparing, in BPSK, you will transfer 1 bit per symbol. Whereas in QPSK, you will transfer 2 bits per symbol. Now, if you are transferring a number of, so when I talk about the channel bandwidth, that's what somebody said, no, channel width. So when I talk about the bandwidth that I'm operating, I will be able to send so many symbols per second, so many different symbols per second. Every symbol can carry 1 bit in the case of BPSK and 2 bits in the case of QPSK and 4 bits in the case of quaternary PSK. Like that, it goes on. So what we are trying to tell is the number of symbols per second actually talks about the baud rate, symbols per second, whereas number of bits that are actually transmitted, whatever symbol you have sent, whatever bandwidth you have used, how many bits have come in 1 second, that is the bit rate. Okay. So we generally talk about baud rate, how many symbols. Now when it is baud, the protocol that is used for transferring will be already fixed. So the number of bits will also be inherently understood from the baud rate. Okay, because it is a specific board, it has got a specific interfacing, wired or wireless, and the protocol that is used for transferring the data is already fixed. All you need to know is at what speed you are using. So it has got a maximum speed. Let us say I can talk very high speed or very sophisticated language to all engineers and teachers. But a nursery kid comes, what should I do? I should speak slowly, I should speak in simple language, I should speak only the topics that are of interest to the kid. Like that, the board may have higher capacity, but you have to configure with certain speed, and the speed should match between the transmitter and receiver, otherwise the sync will be lost. Most often, whenever you get junk data in the HTML port or something, it only refers to wrong synchronization or wrong choice of baud rate. Nowadays, no, the baud rates and all are inbuilt. We are not handling them at all. We don't manipulate them. It is all inbuilt. At the click of a mouse, everything happens. But earlier, it used to be really tough when we used WinTalk for communication. All these things, no, we have to configure the COM modes very seriously. Okay. Now we set the baud rate. We set the pin modes for as output for. You have to switch the LED on and off. So the output has to be given for on and off, right? So we have set the pins for that. And then in loop mode, what we do is simply we read the, so you can make it as sensitive to some LDR, the light dependent resistor that is there. Depending on the LDR, whether the LDR is on or off, based on that, we can make the LED to blink. Some condition on which the LED can start blinking. You can also shun this. This is also not required. You can simply write the LED blinking. Once it is connected, the LED will start blinking. Okay. So the LDR, now let us say it is going to read the value of the LDR, and then we are going to always give a delay, because now can you tell with your knowledge of Arduino, what does this delay of 500 represent? Because we want to know in terms of seconds or milliseconds or minutes or hours. If I say 500, how much time does it represent? Just some answer. Yeah, it's already there. Good. Sanjay Prasad, it is 0.5 seconds. Absolutely. Whatever delay we have is in terms of milliseconds. A delay of 500 means 500 milliseconds. So after 500 milliseconds, then it will change it. Okay, the digital write, it will write the output as high, and write the LED on will be high and off will be low, so that the voltages are given to the LED for on. Similar, otherwise, if the delay is not exceeded, then it is the other way. So if it is on, it will be off. It will be other. Like that, you are going to continue this in the loop. So once this is over, then it will come back to the loop once again. It will read the LDR, and then it will wait for a small delay, and then it will go for this switching on and off. Okay, so this particular, it is not basically LED blinking. I think it will.
Ma'am, I have a question, ma'am.
Yeah, yeah.
Ma'am, can you explain in the term of programming language like pin mode is a function and delay is also a inbuilt function like that? Please explain it.
It may take a long while. All I wanted to tell you is, say, these programming syntaxes that you are getting, okay, all these are only basically library functions. Okay, pin mode means what? You are setting, you are configuring a certain port, the output port or input port, because basically all these pins are IOs. It can be configured as input as well as output. Okay, so I'm going to define a particular variable LED on as an output pin, and this pin mode is a function for configuring this particular variable as an output. Okay, now like that I am configuring LED on as well as LED off. Now serial.println means what? It is going to do the function of reading the LDR. Okay, so from the serial port, it is going to read the value of the LDR value. So the light dependent resistor, it is actually sensing the light, and based on the light that is detected, there is a small resistance value that is generated, which can be converted into some integer form and stored. It is already available in the board. On-board sensor is there and the value is readily available. It is up to you to either read it or leave it. So that is why we are now in that serial.println is a function which is now going to take that LDR value. So you are not taking the LDR, you can take any other value, you are taking the LDR value. Now this analog read of LDR, whatever value is read is stored into a new variable called val. Now this value is stored, and you are, see, these both are the same. Okay, anyway, delay is 500 milliseconds, but if the value means this is the value that is stored by reading that LDR. Okay, if that value is more than 500, then you write this. Okay, now the point is, whenever this LDR, the light dependent resistor, it is reading or it is sensing the light. Now, whenever the light is there, the LED should not glow. Whenever the light is not there, the LED should glow. Like that, the program is designed. So, depending on this value, now this value, how it works, what is the threshold that I can set? You can do even with trial and error. So, we don't know. Full light means what is the value, and zero light means what is the value. For this itself, you can write a code and you can calibrate the LDR. Dark to bright, you can calibrate the LDR itself. Okay, so if the value is more than 500, then you LED on is means the LED is on. Okay, and if the value is less than 500, the LED is going to be off. So this is the way the now how the program will work. You try to close the LDR, the LED will glow. You try to take the handout from the LDR, because LDR will be there on board. No, you can close it or open it. So it will be like that you can, but this is not the program I wanted to show you. I have copied this program. There is a LED blinking program where you can have the LED on and off on a continuous basis. Now you can write the program. All you need to do is give a delay, and you need not read any LDR value. All this can be made as remarks, and you can simply have the LED on and off after every 500 milliseconds. You can have the LED on and off alternately. Okay. Yeah, I have it here. Yes. So making an LED to blink. So what do? Simply you take just one pin of the IO pins. You take one as the output pin mode. Okay. You are configuring this. The digital pin 13 is configured as output, and you now start writing the loop function. Now, actually, no, this does it even require? Yeah, okay, 13. Okay, pin number 13. Yes. So you can actually turn the LED on and off alternately by introducing the delay. Now we are introducing 1 second delay. So what we do here is, we are writing the digital output 13 as high and low alternately after every 1 second. And that pin number 13 is where the LED is connected. Okay, right. So these are the steps that we will follow. You write the code first and then you connect the Arduino. Say Arduino software you will download and you can open the package and you can start writing the code. This code you need not even know, it is readily available. You can download it, copy it, try to understand the code. Now Arduino is now connected to the PC via the USB cable. Once connected, you start control panel, view devices. See, this you have to identify. You see, you have COM ports, you have USB ports. Okay, nowadays we don't have RS-232 ports. Earlier we had that also. Now you must first of all identify and recognize that device properly. And plug and play is also that we can automatically recognize, but you can check once whether it is identified or not. So you start in the PC, go to the control panel, view the devices and printers, and you identify the COM port to which you have connected, because there will be COM1, COM2, COM3. So there will be many USB ports physically, and you would have inserted the Arduino board into one of the USB ports. You don't know which is COM1, which is COM2 or not. So identify that number, that COM port number you identify by going into the devices and printers and view that COM port number to which you have connected the Arduino. Now, in the Arduino development software, you go to the tools, you select the port and the respective COM mode is to be selected. You have to select that COM port to which the Arduino board is connected. Now you click on that arrow icon in that file in the IDE environment to dump the code into the flash of the Arduino microcontroller. Okay, so that is important. Now when you are executing the program, you have to check for syntax errors, and the type of board that you have connected you have to choose properly, and the serial port to which you have connected, like I told you, the COM port, you have to check properly. Whatever type of Arduino board you are selecting, the corresponding library files should be taken and you have to download. For example, you cannot use the mega programs, mega Arduino's library files in the UNO library, because there will be some functionalities that are not embedded into the UNO board. So you cannot use those files. So check whether you are using the right board type and right files, the library files and the programming syntax properly, and then you download. Okay. So this is what I explained in the previous page in text form, and we are now using just screenshots are there to show you how we can use the tools, and then the board you can select and then you can download or burn the bootloader. And this burn bootloader is something different. Bootloader is basically for the microcontroller. You know, the microcontrollers come with bootloader that is already installed and bootloader not installed. What is the difference? The pricing of 200-300 rupees extra will be there. If the bootloader is already installed in the microcontroller IC, I'm not talking about Arduino board. If the microcontroller has got bootloader already installed, then it costs high. So people are making money, like minting money like that. Why should you buy a microcontroller with priorly installed bootloader? You can do it yourself. Okay, you have to choose the right bootloader and you have to do it. So we need some intelligence to do bootloader files and all. We need not do. Anyway, it will be already done. Okay, when configuring itself, it will be done. So this is how we can test the Arduino board for its functionality. You can make the LDR based LED on and off, or you can have an LED blinking program. So two sample programs which will ensure the functionalities are in order. We are confirmed that it is working. Now let us move on to now what is the time? It is 10:15. Okay, I have got another half an hour. Okay, let me try to complete it within that half an hour so that I can give some sufficient time for Bhavatarangini to also do her demonstration. Now what we did was, what I wanted to show you was some sensors that we have used in our own department. All these sensors we have interfaced. And in every sensor we had problems. So I can talk at length about every blessed sensor that I'm showing you here. There was a lot of problems that we faced. I'm not discouraging you. These problems are only enlightening us regarding how we can do the work effectively when we do the next time. Like Thomas Alva Edison said, when he did the bulb 1,000 times, I think 1,000 or 100, I don't remember. He said, it seems I have learned how not to make a bulb with my 999 times of experience. 1,000th time I got it. Something like that it was. Okay. Like that, you will come across certain issues and you can resolve them with your intelligence if you have the mind to do it. So everything will not work immediately, right? Even car driving does not come immediately. You have to hit against some pillar or post to learn, right? Okay. Now LM35 is the temperature sensor. NRF24L01 plus is the RF transceiver, and ultrasonic sensor HCSR04 and pulse rate sensor. These are biomedical sensors. Pulse rate sensor which can sense the pulse from the end of your finger. So the fingertip can be used, or the tip of the earlobe can be used, and the sensor can be fixed there to sense the pulse rate. And FlexiForce sensor, which is like a stripper. All these are available in the lab. I didn't bring all this. I could have showed you also. This FlexiForce sensor is like a small plastic stripper, okay, thin plastic strip, and it can be bent. As it is bent, the resistance will vary. But our problem was we will be applying pressure, but still it was varying. And accelerometer sensor, you may all be knowing, every phone has got accelerometer sensor embedded into it, and temperature sensor. Most of the sensors are there in our phone itself nowadays. Okay, so we can make embedded systems from our phones. Our phone itself is an embedded system on it. Now, temperature sensor, as you all know, it's a 3-pin sensor, and the output is available in the center pin, and you have to give the supply. 5-volt supply should be given, and ground should be connected properly so that the output will come. The sensed temperature will be taken from the middle pin. Okay. Now it gives a linear output here, fairly linear. It's also not entirely linear, and it gives a 10 millivolt per degree centigrade variation. Nice, and accuracy of 0.5 sonanga, 0.4 also is achievable. And it works from -55 to +150, very good range. Okay, current consumption is only around 16 microamperes. You can see it's such a small device. It is like the tip of your, it's like our BC547, okay, transistor. And supply voltage is 5 volts, fine. Okay. Now, what is the problem that we face? I will tell you after showing you. This is how we can interface with the Arduino. This picture is from the website, and you can connect the 5-volt that is available in the Arduino board. Okay, the 5-volt powering pin is there. And I told you 5-volt will be there, and 3.3-volt will also be there. 5-volt is used for all microprocessors, microcontrollers, and other sensor devices that need power. And 3.3-volt is used for some modules like the RF module, heart rate sensor modules. All these things, some modules require 3.3 volts. So we will use that. Okay, so we are using the 5-volt, the ground, and the analog input pin is given to the output pin of this temperature sensor. Okay. Now look at this. We started connecting the temperature sensor. We connected the Arduino to the PC, and we started taking the readings. It was in loop. Okay, every second it was read, and the readings were plotted. Now, what I went for was, for one, the sensor that we took, the temperature readings before calibration. We started plotting it. Okay, you may think it is giving nice values. Okay, you may plot it. But then we tried to compare the temperature readings with another temperature sensor that we have in the lab. Simple mercury thermometer is what we took. Mercury thermometer, don't underestimate. It is the best in terms of its accuracy. Okay. Why FlexiForce sensor? Okay, I'll come to that later. Aruna Kranti, please wait. I'll tell you. That is why we use that. There are so many force sensors like strain gauge and other stuff, right? So now the LM35 sensor is giving values exactly in the same manner for all the time, but there is a What type of error is this? Can you tell quickly in the chat box? What type of error? The blue curve is the readings that we got from the LM35 sensor. Now this temperature standard reference. Red color is the standard reference. Okay, for the same variation. We had a temperature bath and then we started measuring. Now there is error that you are getting in all the blue readings. It's called calibration error, fine. Okay, LNCT, whoever it is. Now, Siju George, you are right. What type of calibration error is that? This graph itself is calibration graph. Okay, there are several types of error while you are calibrating. What type of error is this? Quickly. Okay, what are all the types of error? Yes. Who is that? You said something. Okay. Now, this is a constant error. Why it's called constant error? Because every value is differing by a constant value. You can also have a proportional error, where the error will keep decreasing or keep increasing with respect to the reference. That's also proportional. Both errors are acceptable. Constant error and proportional errors are acceptable. You can calibrate. Non-linear errors are the problem causing errors. Non-linear errors. Calibration will be difficult when it is a non-linear error, when it is neither constant nor there is a proportionality constant. This is purely a constant error. So we could very easily overcome this error by subtracting that value in the software. You cannot do anything with the sensor. So we did it in the software. Like this, I encourage all of you to in turn encourage your students to calibrate the sensors before they even interface with the Arduino board and test it. Okay. Or if they can measure only with Arduino, let them connect it with the Arduino, measure the data, and then go back and refer along with the standard reference, and then come back to the Arduino code, make the corrections in the software so that it is software calibrated. So there is two calibration. There are two calibrations: software calibration, hardware calibration. We are doing software calibration here. Hardware calibration is required in certain. Now let us not go into calibration. It's a very big topic. Okay. Now this LM35 sensor has got nice readings, and we could calibrate, and it would give nice readings. Now I have another question for those who have got some experience with your sensors. Have you heard about DHT11? DHT11. Oh, I'm sending it to somebody in person, from me to somebody. I want to send it to all. Okay. Yes. Varagiri Shailaja. Shailaja, tell me if you know the difference between the temperature sensor that is there in DHT11 and the temperature sensor that is LM35. First, you tell me the cost difference. Shailaja, you tell me, you can unmute and tell me what is the cost difference. Cost. What is the cost of LM35 and what is the cost of DHT11? Okay, let me tell you. LM35 costs around 50 rupees to 100 rupees. And DHT11 costs around 500 rupees to some 1000 rupees. There are some variations. Okay, 800 rupees. 500, above 500 rupees. Why that difference? What makes the difference? If I am measuring the temperature of the same bath, as I am increasing the temperature of the water bath, if I am measuring with LM35 or with DHT11, what difference will I see? But this can be known only for people who have worked with the temperature sensor. Of course, it has got humidity also. Okay, fine.
Ma'am, I believe the accuracy in DHT11 is better.
No, it's not. It's not. Accuracy in temperature readings, which are slow processes, you cannot have a very high level of accuracy. If in digital data, you can talk about accuracy. When you are comparing one digital data with another digital data, you can have accuracy. But this is an analog process where the temperature varies slowly, and there will be some variations, and it's a slow process. So the accuracy cannot be attained, even if you design a very high level of sophisticated sensor. Now the problem is when you're having a drastic change. Suppose there's a hot water, I put an ice block in it. I drop an ice block in that. What happens is the temperature will drastically reduce. When there is a differential change, when there is a higher rate of change of temperature, DHT11 will be in a position to sense faster, whereas LM35 will slowly come down. Okay, so that is another information for you. Now, when we are selecting sensors, you should be careful about choosing the sensor, because if your application has got drastic variations in temperature, better not select LM35. You go for DHT11. Okay. But there are many issues. See, we are all academicians. If I'm an industrialist, I will talk about many other things also. So compensation can be done in software so that the calibration is taken care of very easily. And you can convert it to Celsius, and all these conversions are simple calculations. Let us not go to the high school level of conversions. And you can show the readings as the raw data that is sensed, as the Celsius value, as the Fahrenheit value. You can do whatever you want in the display, you can show that. Now the temperature readings can be transmitted to some other part. So this is where I wanted to just brief you also. We used an RF transceiver to connect it to the same Arduino board so that we can transmit the temperature data or whatever data, sensor data, to a far off place, not far off place, sorry, to another node that is not wired to this node. Okay, that will be a short distance. Now, interestingly, we found this RF module. I have a big story behind this, but if we cut the story short, like Bhagavad Gita comes in very big book, and you also have Bhagavad Gita available small, right? So like that, Bible or Quran also, big books are there, and people will wear it in their dollars. Like that, this RF module that I'm showing you is basically a transceiver that is used in your Bluetooth headset. Okay, it's a Bluetooth device which works in 2.4 gigahertz frequency, which can be used for transmitting the audio files from the whatever phone or whatever to your headphones. Now, in that mode, it has to work with 2 Mbps data rate. But if it is used for sensor nodes, okay, you don't need that high data rate. So we will use the configuration for 250 kilobits per second. Okay, so 2 megabits per second, 250 kilobits, it is 1/4, 250 kilobits per second. So it is programmable. We can program it for 250 kilobits per second data rate, and 250 kilobits per second is the typical data rate that is used in sensor networks. I don't know how many of you are in wireless sensor networks design, and this 250 kilobits per second is also called the low data rate that is used in all sensor networks. Okay, now this small transceiver that is used in the Bluetooth headsets has got it is so versatile. You can do even a PhD research using this. Okay, because it has got so many features that are so attractive. Let me tell you what they are. Now, it works in the ISM band. What is ISM? Industry, scientific, medical. So for all these applications in research areas, you can use this band without paying any license fee. Otherwise, our toy will extract the entire property from you if you are going for licensed bands. So this is ISM band, and it works in a wide range of voltage, 1.9 to 3.6. Fantastic. We love that. We can use for low voltage. We can use it for voltage manipulation when it comes to energy efficiency. 126 channels. What we can do? We can use single channel, or we can combine many channels together and showcase ultra wide band. Okay, all channels put together, we can combine and use it for streaming also. Don't expect any more than this from me, because I didn't do that research. Okay, but it is possible. Combining, I have seen several papers which deal with combining a lot of channels together for bringing about ultra wideband communication, so that the sensor network that works with 250 kbps can be converted into a same sensor network with higher data rates, so that multimedia signals can be transmitted. This is one area of research which is called UWB research. Okay, then you have programmable output power. Fantastic, because my area of research is transmission power control in wireless sensor networks, where I'm trying to control the output power based on the distance between the transmitter and receiver. If you're closer now, if you're all sitting together in a room, no, I will be talking only in this voice. Suppose you were all sitting in an auditorium and I didn't have a mic. What will I do? I have to shout. So the power is like that. In order to reach longer distance, you have to shout. Means that you have to use more power for larger coverage. So when the nodes are close together, why can't we use smaller power? That is another research which we took up, and that was my PhD research, and power control for energy efficiency. That is also there in this small transceiver. And user configurable frequency channel, output power, and air data rate. That's what it means. Okay, frequency channel you can configure what you want, output power you can configure, and air data rate is 250 kbps and 2 mbps. Two different data rates you can have. You can also, I think you can also vary that, but it's readily available. Switching is available. Any other data rate, I think you have to go inside and configure further, and we didn't explore that. So 2 mbps maximum, 250 kbps programmer. 3.3 volt. See, for this module, you need the 3.3 volt output from the Arduino board. And operating temperature is fine. It can work because your body will get heated up when you are using Bluetooth. No? So when the body is getting heated up, the module should not get affected. So it works at even 85 degrees centigrade. So you can use it even when you are having fever, having some hot water bath or something like that. Okay, steam bath. Okay. So the protocol used is also very interesting, but let us not go into the protocol that is being used. Let us say it is we can use it in Zigbee protocols also. We used IEEE 802.15.4 for our communication. Okay, and the internal clock frequency is 16 megahertz basic frequency. You can step it down as you want. And you have the two pins that are used for our communication, which is I have included the pins here extra. I will give you the other pins there. CE pin, which is chip enabled to control the transmit and receive modes. Okay, you can just enable it whenever you want to transmit or receive, or disable it when you don't want. And the active, see, the bus that is connected, it can be made active or low. Means you can virtually disconnect by making it to a high impedance state. So in order to do that, we use the CSN pin. So the enable pin for the SPI bus, the serial program peripheral interface, serial peripheral interface. So that SPI bus can be made active, or it can be enabled by using this pin, which is basically required when you don't want to interfere with other communications. You have to keep it at high value. It is active low. So CSN means N for not, means active low. Okay. So these are various pins. Now this is the Arduino pin to which you can connect it from the RF module. So the RF module pins that are to be connected to the Arduino pins are given here. This is very, very important. If this pin mapping is not there, you cannot interface any module to the Arduino. Be it Arduino board or any ARM processor board or any DSP board, whatever board it is. If you are trying to attach an additional module with the board, you should know the pin mapping. Otherwise, everything is lost. You cannot communicate simply. Okay. So you have the ground, power supply, chip enable, and chip select not, CSN. Apart from this, you have the clock. Okay, serial clock, so in order to make it functional. And the master out slave in and master slave out. That means you can use it as either way. Okay, that bi-directional communication. And you have the interrupt request. Just 1 minute. I need just one moment. Yeah, sorry about that. I had an urgent. So the so these are the pins, and these are the library files for the RF module which have to be included or which have to be used while programming the RF module in the Arduino board. Now this is the program for interfacing the sensor and the RF transceiver along with the Arduino board. Okay. Now what I would like to tell is, since we have very little time, we should have the header files that are meant for the RF transceiver and the sensor. Okay, so you have the RF transceivers header files that are readily available in Arduino, which can be used. For this RF module, we are giving the header file libraries that are readily available in the Arduino libraries. So we can make use of that. Now this RF24.h and NRF24L01.h both are given, which will take care of the communication part. Okay, in from the Arduino's aspect. And then you have you are defining the CE pin and CSN pin in the Arduino board for 9 and 10, and you are going to have this radio programming. See, I cannot explain each and every line offhand, but I want you to realize that this library file is readily available. For interfacing the RF module, this library file is readily available. You can take it, you can write it, and then make only small modifications depending on how you are going to connect the RF module to the Arduino board. Okay, so the RF24 radio function is going to make use of the CE pin and CSN pin, which is the 9 and 10 pins of the Arduino board for its communication, for its serial communication to the RF transceiver. Okay. Now, this pipe is basically used for writing the data continuously. The data that is coming at 250 kilobits per second, it has to be written into the transceiver and then it has to be transmitted. For this, we use a word called pipe. We don't use buffer. Buffer is physically available. The pipes are generally stored in the memory itself, but it will be used as a buffer. Okay, so we create pipe. Pipe nana, pipe. So do you have water stored in pipe? No. Pipes are used for transferring water from one place to another. That's all. But the water will be there while it is being transmitted. Like that, pipe will be used, and we will define a particular register, okay, or location that will be used as a pipe for transferring the information from the Arduino board to the RF transceiver. And the sensor part is going to be pretty much the same. Okay, and you see, we are going to use the radio functions in order to transmit the data from the sensor to the receiver. So whatever you are writing here, instead of simply writing into the file or writing into the output pin or to the serial COM port, we are now using radio dot. We didn't use println or anything. We are using radio dot begin, radio dot open writing pipe, radio dot write. Means what? We are writing the data into that radio files, that RF files, where the data will be transferred from the sensor to the transceiver. And similarly, just like you have the transmitter program, you have to have the receiver program. Now, you can see that whatever you are having here, a constant for the pipe, we are now defining a similar constant for the receiver also, and we are going to receive the information through that through that what to say, through that storage, okay, through that register, let us say. Now you configure this, and then you declare an integer called temperature, and then you start synchronizing with the RF transceiver, and you just start the file called starting, and I mean you sorry, it will just display the word starting, and it will do this begin. Begin means what? The code will start running, and it will open the pipe, and then it will start waiting for the data to come. So it's like Suppose I give you something like let us say some kheer or something. I'm giving you kheer. You have to take it in that. No, I have got in a big vessel means you have to take it. So you have to show me a cup so that I can pour it, right? So like that, the data will start coming, and the receiver should be ready to receive. So the pipe is opened and the data will be received. Whatever data is received will be put into the pipe, and then it can be transferred. Okay, it starts listening. And in the loop form, this is the setup procedure where the pipe is opened while this loop is going to, this is setup and this is loop, where it will continuously keep listening and acquire the data and then transfer it. Whatever it has to do, it will do here. What will it do? Now it will say receiving. Okay, so first it will say starting during the setup, and then it will say receiving, and then when it is over, it will the done will be. I mean, initially the done will be false. When it is over, done will be true. Okay, and while not done, that means while it is not done. Okay, it's not complete. Receiving is not complete. Then done is equal to. That means it is radio dot read of sensor. So you are going to read the sensor. Okay, the sensor data, size of sensor. See, we have declared already sensor, temperature sensor, and size of sensor. Whatever data is coming, that size you take. So we don't know what size it is coming, right? So size of sensor. The data size is made flexible, and then you give a delay, and then you store it in a variable called temperature. You sensor of 0. So that value you just store from that. So these are locations, sensor of 1, sensor of 0, all these are just, sensor is a variable, it's an array. Okay, so in that array, it's a sensor of 0, and then serial print temperature is. So it will see whatever is coming in the serial port, and you are able to capture it, it will show temperature is. And then it will print whatever is in this temperature variable, it is going to print. Okay. And it will put one more line print, means it will go to the next line. So that's what it will do for all. And it will run in a loop. So whenever the data is coming, it will put it in the serial. So like this, we can explain, okay, everything by going code after code, line after line. I think we may not have that much time. Okay. So like this, we have made the RC. Look at how small it is. We have put a pen here to show you that the RF transceiver is so small. It is within that headphone set, right? So it is so small, and it is interfaced with the Arduino board here. And we are transmitting the data. If this LED is kept on only to indicate that the Arduino board is working, you can keep the LED off also. Whenever it is not, if you don't need to waste that power, you can keep it in off also. But we don't know whether it is working or not, no? So we will always put the LED on. Okay, right. So this is how we can interface the RF module with the Arduino. So because the pin mapping is there, we can directly connect it. We can have an interfacing cable which can be inserted instead of having so many wires. We didn't get that cable. There was no such so many pins are required, no 5 pins. We didn't get that flat ribbon cable. So and flat ribbon cannot be connected directly because we are using different pins. We prefer to use this jumper pins itself. Okay, and we can interface with the computer, and we can see if it is a receiver module, we can see the data coming into the. You can open the WinTalk or whatever window. You can serial communication port. You can open and you can see the data. Okay, so we can test it in breadboard first, and then we can make our own processing board also. I think like this, I have got all types of sensor. Okay, ultrasonic sensor, and then healthcare monitoring system using pulse rate sensor, FlexiForce. Okay, I will just answer that question alone. Why did you use FlexiForce sensor? Because this is the pulse rate sensor which can be connected to the tip of the finger, and we can measure the pulse rate. Our campus is adjacent to the railway line, so you can hear nice train sounds. Don't think of your vacation while listening to the lecture. Okay, so the pulse rate sensor can be calibrated with another vital signs monitor. We used Philips vital signs monitor to measure the pulse rate and compare and this is called calibration by comparison. That is also a calibration by comparison only. Standard methods are there for calibration, or you can use calibration by comparison with a standard reference. So we can sense high pulse rate and then we can give trigger, all these things you can do. So for each of this, there is a specific code that you have to write. And if you look at pulse rate sensor itself when you're buying, you can look for the pulse rate sensor and its Arduino code library that is readily available. Download that library, because nowadays, people give Arduino libraries for all the sensors that they're having, so that you can Raspberry Pi code, Python code will be there for interfacing with Raspberry Pi. And for Arduino libraries will be available. You can download and you can use that library and you can interface. Okay. Now, coming to the question, why FlexiForce? Because we wanted to do the walking pattern analysis. So walking pattern means we have to put the sensor in the shoe and we have to observe how they are walking. So people, whether they're using even force on both the legs. So we can put the sensor in the shoe and we can make a very small wireless module connected to each foot and we can start monitoring. We should have a force sensor that is very accommodative of the shoe, foot, etc. So this is ideal for that. As you bend it, the resistance varies widely. As you press it, the resistance variation is little, but it is there. So we can have the sensor put in the shoe and we can measure it. And how to connect it also, we can connect it in the analog pin and it will actually measure the voltage across this resistance. So the voltage will be generated and the voltage generated across this ground and this analog pin will be sensed. Okay. And this is a potential divider basically. And as the resistance varies, because of this potential divider, the resistor will be having a specific resistance, because there is another resistance here. You can very clearly see that there is one resistance here, correct? The resistance is connected in the loop. So you supply the voltage through this resistance and these two resistance, and you have the potential divider point here, so that you can sense the voltage across these 2 points that is going to Now this is a calibration curve that we have plotted for the various voltage variations with respect to the pressure variations. I don't know whether you can see this. See, pressure in bar. Okay, and in accordance with the pressure, the voltage that is measured across the potential divider resistor, because it is basically a passive sensor, so resistive sensor. So walking pattern can be detected, and by measuring the delay and the pressure, the voltage is generated. By making some calculations, we can say whether they are moving with even pressure on both foot or they are applying pressure too much on one foot. So for that, the calibration should be there and the programming should be very meticulously done, so that the thresholds can be set, the delay between each foot, all these things you have to do by trial and error. All these are there. And the accelerometer, we use it for fall detection. So you can use it for movement detection, turning, this, that, everything you can use. We used it for fall detection. So you can interface the sensor according to the diagram that is given. This diagram is from the website. You can connect it and you can program it. Library is also available. Once you do that, how do you calibrate it? So that is in our hands. Okay, all these are available in the website. But what is our contribution? Calibrating and using it properly. So acceleration magnitude, we can measure it for various positions. This accelerometer can be very easily calibrated by keeping it in different orientations, X, Y, Z orientations. It has to show 0 in 2 directions and 1 in 1 direction, X, Y, and Z. It should show 1G because you are not moving it, no? 1G is the gravitational force. 1G is the reference. Okay. No, it will show 1 in 1 direction and 0 in the other direction. If using a spirit level, if you can place the accelerometer sensor in different orientations. Now this will give us the calibration of the accelerometer sensor as such. Okay, dynamic variations we cannot, but statically we can calibrate it. So we calibrate it for different positions and we find that it is working really fine. and we start making measurements. So we make the person to fall. Okay, we tie it with some weight and then put it down repeatedly, and then sideward, forward, backward fall, and we make the measurements. And then we also do sitting postures, getting up and walking, leaning behind, all these things. We saw that the variations are very little in the lower side, and when we fall, it is up on the higher side, like 2 or above. So the threshold can be fixed at somewhere in between with a very good noise margin. So we fixed it at 1.8 G. And then we started programming it using the typical library codes. And for fall detection, we fixed the threshold, so the program should include that. And then we start the variability testing of all the sensors. We can see the pulse rate sensor fixed here, the LM35 sensor fixed here, and the accelerometer sensor fixed in the hips, because if you even tap something with your hand, then it will detect as fall, no? So it should not be in the hand. So it should be only the hip. If the hip falls, definitely you have fallen down. Even if the leg falls, it is not like falling, you may be jumping. But if the hip falls down, definitely it is falling down. So that is the ideal place. So you have to fix it in the hip. Okay. And this is actually not the Arduino board, it is the processing board that we made. But the microcontroller in that is programmed using the Arduino board. And this is the RF module. Oh, sorry, this is the RF module and this is the accelerometer. I think it is so small, I cannot find out. Yeah, now I can find. This is the RF module and this is the accelerometer sensor. So we have used the free website UBDOS. Now UBDOS is a website meant for wireless sensor network data updating, and we have to do some processing there. Python code is required, CoolTerm is required for converting the data into text file and then feeding it to the Python code, so that the Python code can be run in order to update the website with the data, and the website can be used for continuously plotting the data or storing the data, and you can log in and view the data whenever you want. Okay, so we link it using the CoolTerm software. We have to link the text file with the Python code that is going to update the data. Okay, so we write a script file, and it is a standalone executable file which can be run autonomously, and you can link the data that is coming. See, there was a problem dealing with this data coming from the sensor and then the data that we are uploading. There is a lot of processing in between, right? So the conversions were all very difficult. So we use this intermediate software for that conversion, which can read the data received from the sensor through the RF module and then convert it to the or sync it with the code that is updating the website. Okay, so the Python codes will be generated and it can update the file. So we have the UBDOS website. We can show us, this is the Python code and this is the UBDOS website. Like this UBDOS, you have ThinkSpeak. I think Bhavatarangini has used ThinkSpeak only. And you have got several websites that are coming free for interfacing your sensors with the IoT enabled devices, and you can update. Okay. So this is a summary of what I have taken. I am leaving just 15 minutes for Bhavatarangini. I'm sorry about that. I wanted to give her half an hour. Okay.
It's no problem, ma'am. No problem.
Okay. Okay. I would like to introduce Bhavatarangini to the audience. And let me just stop sharing.
Okay, ma'am.
Stop sharing. Wait. Stop sharing. Yeah. So Bhavatarangini, please switch on your video.
Okay, ma'am.
Camera.
Yeah, ma'am.
Yeah. So Bhavatarangini has completed her BE in our department, and she is currently working in Dow Chemicals. And she's a very sincere student, I can say. So I have given her several project phases, and she has completed within a matter of days. So that is why she gains importance, and she's here as part of the faculty development program as a resource person. I welcome you, Bhavatarangini.
Thank you, ma'am. Thank you all for inviting me.
Yes. Please proceed. Yes.
Okay, ma'am. Host is disabled participant screen sharing, ma'am, because being an host, I can't able to screen share.
I think Senthil
Yeah,
also has.
yes, ma'am. I'll do it now.
Yeah.
Okay, fine.
Yes, now you can.
Okay. Okay, can you view my screen, everyone? Yes, ma'am. Can you view my screen, ma'am?
Yes, ma'am.
Okay, thank you. Okay, let me proceed. Ma'am was like explaining about we can download all the libraries from the Arduino which is available. So I just want to show like it is easily available here in the Arduino itself. So now we can see the Arduino platform. So here in this sketch, if you go to the include library and the manage libraries, you will be able to see the libraries which are yeah, the library manager will get open and you can view whatever the library is there. So I am typing here DHT 11. Okay. So in this, the libraries related to the DHT11 sensor will open, and you can see there is a pre-coded softwares and codes already coded by like several company or people will be there, and you can also install it and add it to your script pad. So now just so I'm we can install it and we can include it in our script pad. So now I just going to show the interfacing of the temperature sensor. Wait, I'll share my screen first. Okay, yeah. So here you can see we can download all the code and we can include it in the script pad which I showed it earlier. And this is a DHT11 sensor. And here you can see the pin. So there are 3 pins, and first one is this signal pin, and next one is the VCC and ground. So I seen that Satya Prakash or Satish Kumar, like someone asked if mapping of pins within a wrong pin, if it is going to damage the board. If you connect the VCC to some other wrong pin, it will damage the board. Otherwise, if some small mistakes only, the output will not occur, but we have to find where we have did wrong. So the most important cache should be given when you are connecting the VCC and ground. So if you connect it very wrongly, and that board will 100% will get damaged. So you can see the first ground is connected to the ground pin here. I think everyone can see the ground pin, and this VCC is connected. This is the signal pin, and this is connected to the signal of this the Arduino. And next is the VCC is connected to the 5 volt of the Arduino. So this is the basic connection, and I'm just going to explain a small bit of code which I wrote. So you can see this is the DTH pin interfacing of DTH with the Arduino. So you can see we are defining the header files, and we can also we are selecting the pin number 2. This number is saying that like to which pin we are connecting the sensor. That is the signal of the signal DHT11 signal is connected to which pin of the Arduino. And then we are selecting the type of the DTH sensor, and then the serial communication begins. This 9600 is the frequency which in which the serial communication is happening, and we are saying the DTH sensor to begin its serial communication. So the sensor will start working, and then this is the setup file, and next is the loop thing. Here the loop is the portion where it continuously keeps on running for a respective period of time, or for a specific condition. So I have just introduced the humidity that is as a float integer, and this is the since it is a library, DHT is a library, and there'll be an inbuilt function in the library, and if you put read humidity, it will read the humidity the factor inside by the sensor. So we are declaring the h as a variable and storing the humidity in it. And next is the temperature. There is a temperature factor, and we are saying it's a dot read temperature. It's already is there in inbuilt in the function which I've downloaded. And then we are checking the, this is the main function. So we are checking the isNaN function is this function will help us to test whether it is not a number which it returns when it is true. So if when the sensor start reading the when the Arduino board starts sensing the sensor, if it is not reading any sensor, it will return a value. So that if this condition becomes true, we can say that a sensor is not working. So it should return a value. It should return a number. When it's not returning a number, this condition becomes true. So we are testing whether sensor is working or not. And then if it is not working, we will move to the next else function. And here we are printing the temperature and the humidity which we got it from these functions. So this is very simple thing. Likewise we can do for other sensors. So I just have a small video of it so that you can see here. I think anyone can hear this video. So here you can see. Okay, fine. Okay, let me explain it. So here they have connected the VCC to the 5 volt and the ground to the ground pin, and the signal to some of the numbers of the digital pins over here. So you can see the connection here, and we have to write the code. I'll just move forward the video for a shortage of time period. So this one I showed you. So we have to we have to type whatever the sensor name, and we can download the a specific package, and we can print it in the we can open the sketch and we can save it, and we also can run it. So I will just forward it, and I will show the video of it. So I'll show the final outcome, how it occurs. Yeah. So this is the serial monitor, that is 27 degrees Celsius and 38 humidity. So relative humidity. So likewise we can interface any of the sensors. So this is a basic one. We can start with the temperature sensor and move on to the piezoelectric sensor and ultrasonic sensor and many other sensors. So this is the one part of a small thing which I decided to show. And the next thing I just want to share is like me and my Sabitha ma'am and me, I just done the project on IoT based monitoring and control system using the LoRaWAN. Like, what is LoRaWAN? It is very similar to the RF receiver. What ma'am was explained before. What is the difference is this? What is LoRa means? It's a low power. It's a low power wide area access. So I will just move, and you can see this is the LoRa module. This is the LoRa module. So here they are having an inbuilt processor which is built by the Semtech, that is XX1272, and they are having an inbuilt DI inputs, some AVO inputs, and I2C communication ports and UART ports. Everything is inbuilt in this module itself. So the main advantage is that it consumes very low power when compared to other Bluetooth module or RF receiver. That is the main advantage, and it also can transmit the signal at a very longer distance. So this is the main advantage of this. So what I did was so this is the architecture of the LoRa. You can see there is different classes of this, class A and class B and class C. This LoRa, it operates in the MAC layer, that is medium access layer. And in India, we have to there's a specific frequency band in India, so that we can you can use this LoRa, that is 868 megahertz. So, and then I will just move forward the. This is the main block diagram of the project we did. So there is three nodes, and three nodes will be sending the data of the temperature sensor and humidity to the coordinator node, and the coordinator node will just serially connected to a single channel LoRaWAN gateway. So what we did is like single channel LoRaWAN gateway. If you go and search in internet, it costs up to 40,000. So what we did was we connected we used the Raspberry Pi model AB and connected to the LoRa and made it very simple, so that it cost up to 300, because the LoRa will cost up to 3000. So we reduced the cost to up to 3000, and this Raspberry Pi connected with the LoRa will communicate to some IoT web page we created. And then one and the next second thing was what it was like, from the IoT web page we can control the end nodes. If you I will just show the screenshots of it so that you can understand more. I'll just move forward. This and all inbuilt. Yeah, this one only I'm saying about the nodes. So which we created. This is the node one. It's the end nodes. It's having a LoRa under which you can see the Arduino. It has been the pins has been connected to the Arduino, and you can see a DTH sensor here, and it's connected to the battery. And this is the one node which I was saying. And then I said like we created a gateway. Here the LoRa module connected to Arduino, and this is Raspberry Pi. These both are serially connected, and the Raspberry Pi is powered up with the power bank power supply. So this is the whole setup, and I can show this is the whole so here you can see the end nodes which I showed, 3 end nodes, and there is a gateway, and there is an IoT web page. So I will show the IoT web page which we created. This is the IoT web page we created. It's an open web page. We can customize to our needs, and we can log in with our credentials, and they'll be having separate key for it. So what you can see is that if you off the node one, the node one will stop running, stop sending data to the gateway. So it's a closed feedback system. So we created a closed feedback system, and whatever the temperature of these nodes, you can see it here. So you can see, I will just zoom it a little bit. You can see, wait um, you can see the temperature of node 1, node 2, node 3, and everything is set. And if you off this node 1, the node 1 stop sending data to the coordinator node. And if you stop node 2, it will stop sending the data to the coordinator node. So this is the project we created, and I just want to share the basic idea of how it is done. So here you can see in this web page, there's also an history involved in it. So we can store the history, and we can store the if it's anything goes wrong, we can come back and show. We can see where it has gone wrong. So there's also a provision for that. And these are the this is the control action we did. So I'll just have another video to show you. I'll just so this, I think the video will be somewhat blurred, but anyway, this window is from the Raspberry Pi window, and this is the IoT web page which I showed. So you can see the continuously the data is getting updated, and you can see the gateway, and there's also the 3 nodes is connected to it's wirelessly connected. It's standing independently, and it's sending the data to the coordinator node, and then it's the gateway to the gateway, and the data is also updating in the IoT web page. So this is the overall project I did in my final year with the guidance of the Sabitha ma'am. I have to thank her to providing the essentials for me and guiding in a correct way. Okay, ma'am, I'm done in my part. I think so. I just is there anything you should add upon? You can add.
Very nice. Thank you so much, Bhavatarangiani. That was
Thank you, ma'am.
comprehensive, I should say.
Okay,
Very
thank
quick.
you, ma'am.
I think I didn't allow you too much time because you had to skip a number of slides in between
Yes, ma'am. Yeah.
because of the shortage of time.
Okay.
Okay. Now there is something coming up in the chat box. Let us see what it is. Will there be very informative? Okay, that is there. Thank you so much for telling us that it is informative. We also enjoyed the session. And will there be any telecom regulatory issues as we are not using the ISM band? No, that is also ISM band. Siju George, actually 868 megahertz. There are many bands that are ISM bands. Okay, one of them is also 868 megahertz. We only talk about 2.4 gigahertz because it is Wi-Fi. We are very familiar with that. Whereas the other ISM bands, we are not very much familiar. There are 950 megahertz band, 868 megahertz, 433 megahertz. All these are ISM bands. Okay. Yeah. Anything else? Any other question? Using DHT read temperature, will voltage be converted to degree centigrade directly instead of writing the equation?
There's also two ways, Vijay Karthi, sir. Either the code which I showed will be converted directly to the degree Celsius. If you're using a different code, we have to write an equation, separate equation for the conversion of the to the degree Celsius. So it depends upon the which code you are using, the data set you're using. Yes. Okay. Okay. I think that's upon the. Okay. Thank
Okay,
you.
and there is another question. We have a register that is recording wind speed. Sometimes a faulty data is observed, like a nominal value is 4 to 6 meters per second, but value for like 99 appears. 99 on you should see the manual. It may be the overload. See, for every, even in washing machines, we can see that there will be a specific error number that will appear. Okay, like you may all be familiar with 404. Okay, server not found error. Like that, this 99 may be value telling you that it is either not connected or overflow or something like that. So you should read the error code in that manual. Okay, for the data logger. Data logger will give you the details. Okay, you can try. I'll tell you one simple thing that we observed when I was working earlier in the company. Whenever the connectors or the particularly data loggers are kept in open space, and the connectors are the data cables and the BNC connectors, all these may be there even in that open. So what we do is we switch off everything, and you have some cleaning solution that is called, earlier we used to say WD-40, which is meant for removing the oxidation coating. Removing the oxidation coating from the surfaces. It can be metal or alloy or whatever, the oxidation that is formed. So use that spray and then just wipe it, just scrub it. It will work very well. The pins may not be connected properly. Okay, the ohmic contact may not be there because of some deposit or whatever, or some losing, some loose contacts or whatever. So you can clean it up with this cleaning solution that removes the oxidation coat mainly. It's not the soap water, it is the oxidation coat remover. So if you use that, it may work. That is one thing, and look for the manual for the errors, specific errors. Second thing. Okay. Yes, what else? Yes, Vijay Karthi says, got it, thanks for Bhavatarini's answer. How to interface sensors like TGS 2600 with Arduino? You have to look at the library files just like it was shown. See, first thing is, whenever you look at a sensor, you try to buy a sensor, you should check whether the sensor is a microcontroller compatible sensor. Any microcontroller compatible sensor will work with Arduino. And there are specific sensors that come with Arduino files, libraries. And if you buy that, what is the TGS 2600? Samujal Barua, can you tell what sensor it is?
It is basically a gas sensor.
Gas sensor, okay. There are several gas sensors that are directly Arduino compatible. I'm not sure about this number, but I didn't hear this number. There is a number.
Samujal, this sensors will not be, there's not a separate library for this to access the sensor. We have to code it in our own way. Like there's not any pre-built library for this sensor. Like we have to code it by our own.
Okay, you can see the data sheet of that sensor, and then you can code, because if it is microcontroller compatible, You can connect it with Arduino board and you can start programming it. See, the programs, don't think that libraries means you can use it directly. As I told you, calibration is required. As for the Bhavatarini's project, they did some specific usage for their communication. Like that, you have to write your own code apart from the readily available libraries. Libraries in the sense the header files that are there for the interfacing part. So you may take that and use the header files and start coding for your specific requirement. Okay. And when you the PWM signal for driving motors, no, you should be very careful. You need motor drivers. So without a driver, it may not work because the current driving capability of this PWM output with specific capacities, you cannot use them directly. Okay. Yes. So if there are no more questions, I think our session is done and we have taken exactly the right time, I think. Yes. Okay, over to Dr. Sendila Rasu.
Thank you, ma'am. Actually, very interactive
Ma'am,
and
may
informative
I
session.
have your mail ID, please?
Pardon?
May I have your mail ID, please? And thank you very much for the informative session. Thank you very much.
Oh, thank you so much. Thanks, Bhavatarangini, for I think it is amidst your office work you have come here.
Thank you, ma'am. Thank you for inviting me to this session, presenting to all the professors. It's an honor for me to. It's a pleasure.
We enjoyed it too. It's always a pleasure to have good students doing work as we did. I'm just typing my mail ID. I don't know how to send it to everyone. Okay, send. Is it coming to everyone? It is going to direct message.
No, ma'am.
I don't know. It is going to Siju George alone. Chat to everyone, every for the engineer. It is going to them. Yeah, here to everyone. To everyone. Yeah. Now I can type one second.
No, it's there, ma'am.
Yeah, you sent it. Okay, fine. Now I selected. Your name was there. I tried selecting. Okay.
Sijujar sent to everyone.
Yes. I saw that just now. Yeah.
Thank you, ma'am. Thank you, ma'am, and Bhavadani also for giving a live demo of some sensors interfacing. And yeah, actually, it is a very interactive and informative session, ma'am. Thank you very much. And,
Thank you.
On behalf of the institution, I thank Sabith ma'am and Bhavadani for taking a wonderful session today morning. Thank you.
Thank you.
Dear participants, please connected. The next session is on about Arduino IDE, and the research person is from industry. It is Shiv Robotics, and CEO of the Shiv Robotics is here. Sir, Shivakumar sir. Sir, join பண்ணிட்டீங்களா? Participants, good morning. I'll share the feedback link shortly in the WhatsApp group. So the next session actually we're about to start. So the resource person already joined here. So next session is on about Arduino IDE, and resource person is Mr. R. Shivakumar. He is the CEO of Shiv Robotics Lab in Erode, and he obtained his BE in ECE department, Electronics and Communication Engineering, in the year 1997, and he joined in Aptel in the year 1998 as a Deputy General Manager Technical, and worked for a period of more than 16 years in Aircel, and he also headed the South Prepaid System Technical Team. Then he started his own R&D lab named Shiva Robotics, and he is also a manufacturer of 3D printers, and he is doing R&D works in embedded system IoT. He has established a very well equipped robotics lab for R&D purpose in Erode, and he has also conducted a number of workshops for students and faculty and provide hands-on training in IoT in embedded system in various engineering colleges and polytechnics, including Anna University. So he is very versatile in IoT and embedded system, and he is having a lot of practical knowledge in this robotics, IoT and embedded system. So participants can make use of him for doing the project works and set up any IoT labs, embedded system labs, etc. And he is here with us for today. He is going to handle a session on about Arduino IDE. I request Shivakumar sir to take over the session, please. Shivakumar sir, please.
Thank you, sir. Sir, am I audible to you?
Yes,
Yes,
sir.
sir.
Yes.
We start this session with an irrelevant picture. I hope everyone is seeing my screen share. So, are you seeing that first screen? Think out of the box screen.
Yes, sir. Yes, sir.
Yes, sir.
Yes, sir. Okay. So, the first session, in an unethical way, we are starting with the screenshot showing a whistle, an irrelevant picture for our session. Anybody is having any idea what is this whistle picture shown for? Anybody has read the story about this whistle? Okay. The story begins in 1960s when the first electronic telephone exchange was implemented by AT&T engineers. They were facing a very strange problem. Suddenly, the calls are getting disconnected. When people were speaking, calls were getting disconnected. On further analysis, they found that some kind of fraudulent calls were therein. Somebody was making prank calls. Somebody was making long distance voice calls without the knowledge of exchange. On further exploring this problem, they found that the problem was because of the in-band signaling. There is a disconnection signal, which is 2.5 signal, which is being generated from the telephone when you hook up the telephone to disconnect the call. The problem was found when the call was on a conversation. When the particular signal is being generated, the call was getting disconnected. Somebody was using this kind of methodology to make a long distance call. Then they started exploring what was the problem for generating this kind of signals. In 1960s and 70s, there was a serial box which was sold in the market. They were giving a free whistle with that box. Surprisingly, this particular whistle was producing exactly 2.4 kilohertz. So when you are making a call from your home, some of your children is having this whistle. If they are using that, then the call is getting disconnected. This is where the first and foremost SS7 outband signaling experiment started. So they've removed the control signal from the voice and they made a separate channel for sending control signals. This is where SS7 born. And this is the period for DTMF signal. I think most of you people are aware of DTMF. This is where the DTMF also came in. If you see that, these two technologies were ruling the technological world, that is a telecom world, for more than 5 decades. And this is where the next technology, VoIP, was on top of that. If you see that the problem origin, it is not related to an electronics, but it is related to some kind of other department or some kind of other set of issues coming around us. But we engineers will not stop analyzing the problem as a technical perspective, but we will cumulatively analyze and find the solution for the problem. If this is true, we engineers make the world. Welcome to the fast track Arduino course, and I am Shivakumar from Shiv Robotics. We have so many fascinating stories to discuss, but if we have time, then we'll have our discussion after this session. First thing first, when we are saying that Arduino, what is Arduino? So this is where actually we were discussing about the story of the whistle. We as an engineer, when we are trying to understand a technology, we always go bottom to its origin, where exactly it started and why it was started and what was its advantage, whether it can sustain for the future proof purpose. If I'm saying that I'm going to use Arduino, whether Arduino is suitable for me, the first question. And what is Arduino is the first question. Whether the Arduino is suitable for me is the second question. Whether Arduino is foolproof or future proof. Can I use it for my industrial purpose? Can I use it for my day-to-day home automation purpose? So this is the third question. So we are going to find out answer for all these questions in this session. So you have the responsibility to stop me anywhere you would like to discuss. We can stop there, discuss, and move forward. Okay. So what is Arduino? The name itself is very strange, right? Arduino is something, not a kind of name which is available in India. So why they given some kind of name junk Arduino? The origin started from microcontrollers. When back in 1980s and back in 1990s, microprocessors were there. I think most of you might know 8085. We all worked with 8085. Then after that, 8051 came in, which is a microcontroller. So there are two terms, microprocessor and microcontroller. You have any idea what is the difference between these two? This is an interactive session. You can interact with me at any time. Okay.
Inbuilt memory.
It's an inbuilt on-chip RAM and RAM.
Exactly.
For microcontrollers.
Exactly. Microprocessors will not have any peripherals. Microprocessors will only do a processing. That means it has only arithmetic processing unit. It doesn't have any peripherals attached to it. If you would like to control something out of microprocessor, you need to add a peripheral which can control outside world. If you would like to have more memory, then you have to add a memory chip additionally. If you want to keep your program, the microprocessor, you have to keep a separate memory for that. So that is the hindering factor for 8085. On top of that, we developed microcontrollers. So microcontrollers, what it does, it includes all the peripherals inside. A microcontroller can have memory inside, A microcontroller can have input-output controllers inside, a timer inside. So whichever peripherals you would like to add, we can add. Now the problem is coming in microcontrollers. What microcontroller should I use? Whether any specific set of microcontrollers available, like 5 or 6 microcontrollers available, I can choose it? No. It is 50 odd manufacturers are available in the world. Each manufacturers are doing hundreds of microcontrollers. Now the problem is that which microcontroller should I choose for my application? I can go for Atmel, AVR, or I can go for microchip PIC. Now Atmel is coming under microchip. Microchip has taken over Atmel. So microchip is both the microcontrollers. Which one should I go? Or should I go for Renesas? Should I go for TA microcontrollers? Should I go for STM or ST32? Which microcontroller should I choose? When it comes to microcontrollers, then again, we are going to analyze which is cost effective. Then we are going to choose which microcontroller is suitable for me. First thing, whether it is cost effective. Hope I am audible, right?
Yes, sir.
Yeah, thank you. So which microcontroller should I choose? That is the first question. So the reason is that we have so many options. When we are choosing microcontrollers which is cost effective, the problem will come when I'm programming the microcontrollers. I don't have the tool for programming the microcontroller. Then I have to purchase a separate tool. So which tool should I purchase? Whether one tool is enough for me to program all microcontrollers? Again, the answer is no. Each microcontroller is having its own set of programming interfaces. So that means if I have multiple microcontrollers, I have to purchase multiple tools. Okay. I choose a set of microcontrollers. I choose a set of programmers. Now comes to programming. Which language should I use? Should I use C? Should I use C++? Basic, Pascal, Python? Whichever is suitable, should I use it? Again, there are so many solutions available for programming. And again, it is going to be a confused state. Which combination of microcontrollers, programmers, and programming languages should I use? So this is where the first problem solution was started for Arduino. A student in Italy teamed up with his mentor. He started working for a microcontroller simplification with the help of a header called wiring.h. There is a single header file which will define the pin configurations and how it is being mapped and how it is going to be used for a microcontroller. He tries to simplify the use of microcontrollers. They first actually manufactured a test board within their Italy university lab, 10 odd boards, and they would like to use this for teaching their students. First hindering is that microcontrollers, programmers, and programming languages. Second hindering factor is that teaching the programming languages from the scratch. If you remember, start studying C++ in the earlier days, it will take 6 months to 1 year. That is the life cycle. We have to start from the variables. Then we have to slowly build up our knowledge for programming a small routine. Then we'll try to make functions. Then after that, we are going to study about classes. Once classes are coming into picture, then whoops, object-oriented programming is coming into picture. So the complications are slowly building up. But ultimately, what is the target for us? We need a simple programming language which will specifically target for a microcontroller. So that is the only requirement for us to teach our students or to work with microcontrollers. Why should I go for an in-depth study of C++? So that is the first hindering factor. So What they've done, they made a small hardware and they made a small library and they made a programming interface based on processing language, and these three are ecosystems for programming. Why they've chosen chosen the processing language? The time processing language was picking up, and it starts with only two loops. One is setup loop and another one is main loop. There are only two loops, and processing language was specifically targeting even non-technical people as well for making drawings. So that was a very simple IDE. So they've adopted that programming language for Arduino. With that, they made a small hardware, simplified programming language, and then front-end GUI, so that they can start programming as quick as possible. So what are all the problems they solved? First thing is they fixed the microcontroller, which microcontroller we are going to use. Second problem, they eliminated the requirement of programmers. How do they eliminate it? They made a small bootloader inside the microcontroller, so that microcontroller itself can program itself. So that way they reduced the processing programming hardware. After that, a small GUI based on Java they've developed. With that, they made a small ecosystem. Okay, so up to this, we know what is the problem and why the Arduino has come in. And now still we don't know why they've given the name Arduino. Why they've given Arduino name? Microcontrollers are starts with 80 mega, 80 mega 328. Okay, 80 mega 128, pick 16F 877, or pick 18F. So this kind of names are there, but for the whole system they've given the name Arduino. The reason is that the team which was working for this project, normally they meet in a bar called Ardin in Italy. So they given the name Arduino. As simple as that. Do you have any idea what is IEEE 802.11? What is IEEE 802.11? Some kind of alien name. What is that? Do you have any idea?
So Zigbee.
Not the Zigbee. Any other answers? IEEE 802.11. It is
Chat
Wi-Fi.
box. Sir, please check chat box also, sir.
Yes, sir. Okay. Actually, it is a Wi-Fi. IEEE 802.11 is Wi-Fi standard. So we can
in chat box somebody posted, sir.
All right, sir. Okay. Yeah, they've already posted. Great to see. So if this is the case, why do we give the name Wi-Fi? Why should I give IEEE 802.11 some kind of alien name? I can simply say Wi-Fi, right? So that will make usable for both worlds, the technical world, non-technical world. Everybody can easily understand. Why they've given IEEE 802.11? Because we are engineers. We are doing this way. We are doing always in our way. The reason is that engineers are too lazy to give a fancy names always. IEEE is the standard. 802 was the chapter. Point 11. 11 is the 11th experiment which was going for Wi-Fi. So the engineer who was working for this project, he simply named IEEE 802.11, as simple as that. So nothing to be remembered. Google is your friend. Whichever thing you would like to know, just Google it and take it from there. So no need to memorize anything. So if this is the case, Arduino, the name itself doesn't matter anything. All it matters is that they've given a fancy name. That's it. They were sitting in a bar. It is called Arduino. So they've given the name Arduino. And the Arduino was retained because these people were working for Arduino. So this was the history of Arduino. So the point here is that we engineers don't afraid about technologies and don't afraid about the names. It doesn't imply anything. It is all going to be break down into small pieces. There was a question which was asked somewhere in the interview. How do you eat an elephant? Your mouth is so small. The elephant is so big. How do you eat an elephant? Suppose if you would like to eat an elephant, how do you eat it? What is the answer for that? At least what is the known answer for that? Something we want to eat it, right? How do we eat it? Whether it is an elephant or it is a small burger, eating is bite by bite. I'm going to eat bite by bite. So that is the only thing I know. So if that is the case, all complicated problems, we can break it down to a small piece which we can understand. From there, we will build understanding one by one, one by one, one by one. So all complicated technologies, you can easily understand when you are breaking down to small pieces. If you would like to know what is VoIP, just break it down and go till SS7. And if you would like to understand what is SS7 signaling system number 7, break it down to in-band signaling, which is very easy to understand. So from there, we will develop our knowledge. So Arduino has started like that. When microcontrollers were alien that time, they started making a small setup which a student can easily understand and start programming it. Once he started programming it, he can explore his own way of controlling microcontrollers, and we can make his program more complex. So that is how Arduino started. Okay, so far we have discussed what is Arduino. Now the big question is Arduino, whether it is a hardware or it is a software. What do we understand so far? We were discussing about Arduino. Somebody was creating a hardware. Somebody was channelizing the programming side, and a front-end GUI was created. Now the question is, when we are saying Arduino, whether it is a hardware or software. It is hardware, useless without software. Okay. Is there any better way of putting it?
Arduino is an embedded system that is hardware as well as software. Both are included.
Both are included.
Hardware with an IDE interface which users can understand.
Okay. So this is where we are defining the term called ecosystem. Arduino is an ecosystem. That means if you say that you are saying that EV is picking up, right? Right now the current trend is EV, electric vehicle. If you say that I have an ecosystem for EV, what it does mean? I have a complete set of hardware, software, tools, programming languages, setup, everything is available under the umbrella. So that is what we call it as ecosystem. So whenever we say that, you have to keep in mind that Arduino is an ecosystem. It is a mated pair of hardware and software. It is a mated pair of hardware and software. So whoever is going to work for Arduino, they have to meet a set of rules so that they can modify, change, or write a new program or new set of hardware according to Arduino setup, and they can push into Arduino ecosystem. Coming into the Arduino ecosystem, it will work in the same way like any other Arduino hardware or software works. So what we are understanding is that Arduino is an ecosystem. Most of you people has correctly answered. It is a combination of hardware as well as software. So here on, what we are referring is that Arduino is an ecosystem. That means it is self-containing umbrella where mated pair hardware, software, libraries, everything is available under Arduino. So far what we have seen is that why Arduino has come in. Arduino has come in because there are so many complications when choosing microcontrollers. Making it, we have to make it as easy as possible to program it, and we have to take out some kind of problems. So all these things were taken care by Arduino. When it was started, Arduino was what is the year Arduino was entering into the market? That is again interesting stuff. This kind of instances are only happening in technical area. First, actually, they manufactured some 10 odd Arduino boards. They used it within their university, and the demand was so high. So they again produced some 100 numbers of boards. Some of the boards were not used in the university, so they sold outside. Once they sold outside, demand has gone up. People are started asking, they want more Arduino. So that is where Arduino manufacturing setup was done in Italy. So first Arduino manufacturing started in Italy, and still it is producing Arduino boards. If you are purchasing this Arduino board from Italy, it is almost 10 times costly. As usual, we have a backdoor. If you would like to purchase it from China, it is 10 times lower. So we always have a solution. Even a problem with the price, we have a solution for that. So anyway, Arduino has started in 2011. Now we are in 2021. Whether Arduino has evolved? Much evolved. Arduino has slowly evolving into capturing the market in 2016. And 2018 onwards, it is all much matured boards were there in the market. Even sometime Intel was there with Arduino, producing Arduino boards like Intel Galileo and other boards. He was supporting, he was producing boards for Arduino, and he stopped now. But there are still major players still working on Arduino. Atmel is already there. Atmel is the origin point for Arduino. And TI microcontrollers, they have their own set of Arduino setup available. ST microcontrollers, they started supporting their microcontrollers with Arduino. So many boards, so many new technologies started coming into Arduino. And once this kind of new technologies were pumped into Arduino's ecosystem, they started slowly making it nagged. That means Arduino can be used as a ready-made product, a ready-made solution with the inbuilt set of which you can very well use it. That is more than enough. But I am a technical person. I want to tweak everything. It is also possible. That means I can do a programming purely in C, C++ stack and use the Arduino environment to program my microcontroller. So that is the power of Arduino. Arduino has evolved to a point that it cannot be neglected. It is inevitable now. So now Arduino is also available in Industrial 4.0 standard. The reason is that Industrial 4.0 standard now includes Wi-Fi, machine-to-machine communication. So Arduino was the best, is the best solution as of now for Industrial 4.0 as well. So that means if we are started studying, we are going to be top-notch in technology in embedded systems. So if somebody is saying that Arduino is only for hobby grade, please refuse that. Arduino is not for hobby grade right now. Arduino is now catering from hobby grade to industrial grade. It is there everywhere. Arduino is giving you a super set of tools which can be easily programmed, which can be easily distributed, all these things. Okay. So that means Arduino is a technical invention started in 2011. Until 2021, we were evolving, right? So is that a smooth ride for Arduino? There is no controversies. Nobody has claimed that this is my board, this is my software. Any copyright problems? Arduino has gone into that kind of crisis as well. There were at times, there were two different types of Arduinos. One is plain Arduino and another one is Arduino TM, RTM to be precise. LLC Arduino was registered by somebody in 2015, and there were two different vendors claiming that Arduino is their property. Around 2016 and 2017, amicably it is settled down and it was made as open source. Since it is open source, every technical person available around the world started developing programs and libraries for Arduino, and Arduino was started growing stronger and stronger. So the understanding so far is that Arduino has come a long way and it is well matured and it is ready for production, even for industrial standards. This is what we are going to keep it in our mind for the first two slides. Before going into Arduino deep, you have any doubts, we can discuss here about Arduino, then we'll move forward. You have any doubts or anything that we would like to discuss, we can discuss now. Okay, we are proceeding now. So now we know what is Arduino ecosystem. So how will it look like? How an Arduino will look like in a hardware perspective? So these are all some of the example boards. They have retained the name Arduino. After that, they have given a nomenclature based on the type of board they've used. The first board was released was Arduino Uno. The left-hand side first board, that is Arduino Uno. That was the one actually released. If you see that board, there is a microcontroller which is a 28-pin DIP, which is there in the center of the board, and there is a USB connector. Back to the USB connector, there was a rectangle chip. These two chips are mandatory for this board. After that, you have a power connector and edge connector. All these things were there. So how do they design an Arduino Uno? Again, we go back to the problem. First thing first, we have to fix the microcontroller. Which microcontroller we are going to use? So we have fixed that we are going to use Atmel microcontroller. It is called ATmega328. ATmega328 is having 32 kilobytes of flash memory and 2 kilobytes of RAM, 512 bytes of EEPROM. After that, I have a microcontroller in hand now. So how do I program it? The traditional way of programming Atmel microcontrollers are based on SPA interface. SPA interface, if we have time, we will be discussing this session. Otherwise, we will be discussing on sensor interface session. Serial peripheral interface is the port which is available in ATmega328. That port is used to program the microcontroller. Again, that needs a special hardware. So how do we solve that problem? What they have done, all microcontrollers from Atmel, it has a bootloader memory, which is residing in bottom of 32K memory. That means a 32K flash memory, the bottom 1K, 2K, 4K memory can be used for programming bootloader. So you will be able to send the microcontroller's starting point to the bootloader. If something is coming, bootloader will take care of that. Otherwise, it will come back to the address 00 where your program starts. So that way, they put a bootloader inside the microcontroller. So now the bootloader is there inside the microcontroller. That means serial peripheral SPA interface is not required to program the microcontroller. Now, what is the next point? To invoke the boot controller, we have to communicate in a serial interface. For that, they put a USB to serial converter, that is the small rectangle chip, which is behind the USB port. So how do they work? Once you plug in your Arduino Uno to your PC, the rectangle chip will create a COM port in your PC. That COM port can be used to send programming instructions to the main microcontroller. Once the instruction is coming into the microcontroller, a reset pin will be activated so that it is going to the bootloader mode. Bootloader will take care of programming the microcontroller itself. So it starts getting the instructions from the serial port. That instruction sets are being programmed to the memory which we want to programming it. So that is how they designed Arduino Uno. This structure was very effective and it was working flawlessly for years and years. So almost all the vendors started adopting this procedure. Once this was successful, Arduino Uno was successful, they started developing other type of boards as well. As you can see in the Arduino Uno, there is a set of connectors in the edge of the board. These connectors are standard. That means if you would like to buy kind of testing hardware, or if you would like to buy some kind of interfacing hardware for Uno, you have to specifically tell that I want a shield for motor control for Uno. You have to specifically mention, I want to have a shield for controlling motors for Uno. If you are asking that, you will be getting a shield. That shield can directly sitting on top of Uno. From there, you can map your pins and you can control it. So these pin standards were retained for Uno and Leonardo. Other microcontroller boards were following up after Uno. So first thing first, Uno has come into picture in the early. Once it was successful, the next one was Arduino Nano. The problem with the Uno, you can see that the board is all having female connectors, right? If I would like to use it in breadboard, I have to use jumper cables. From Uno to breadboard, I have to use a jumper cable. From there onwards, I can interface my testing hardwares. That was a painful thing. So this is where Arduino Nano has taken over. Arduino Nano was coming with a small form factor with all the facilities packed in. Nothing has left compared to Uno. All the facilities are available in Arduino Nano. Additionally, we have two ADC pins also available in Nano, but Arduino Nano has come with male connector. That means Arduino Nano can easily be pushed into breadboards where you can use for your experiments. Normally, people will ask when they start using Arduino, which board should I buy? Should I go for Uno or should I go for Nano? Which one is suitable for me? So how do you feel? Which one you will choose? Would you go for Uno or would you go for Nano? Which is your preferred choice?
Nano.
Nano is your preferred choice. What is the downside of it? As we discussed earlier, Uno is having a vast set of shields available in the market. That means if I would like to control a DC motor, I can easily get a shield which can directly sit on top of Uno. I have no wiring, nothing. I can simply plug in the module and I can start programming it and I can control the motor. If I would like to use a sensor board, I can go for Uno sensor shield. I can straight away use it. If I would like to use for a Wi-Fi shield, I can directly use it and I can programming it. No wiring required. When it comes to Nano, it is very cost effective. It is breadboard friendly, but the problem is that shields are very, very low. There is no ready-made shields available. We have to use it on our own. That means we as a technical person, if an end user is, not too technical person, if he is choosing Arduino, then he will go for Uno. If technical people like us, if you would like to use Arduino, we always go for Arduino Nano. The reason is that it has everything, but small form factor and it is a breadboard friendly. Why the cost is very low? What exact features we are missing compared to UNO? We are saying that all the features are available in Nano, and even 2 additional ports also there in Nano. Then why the form factor is slightly bigger and this is very slow, very low, but still it is cost effective? As you can see in Nano, apart from a main microcontroller and a small USB to serial microcontrollers, there are some SSOP chip and a separate regulator, capacitor, all these things were there in the power connector side. The small 8-pin SSOP pin is actually a LM328, a dual op amp, which is used to sequence the power. If you are plugging in the USB, then automatically it takes the power from USB. If you are plugging in the AC, that means a DC 12 volt, then the 12 volt will be automatically sequenced, used in the regulator, and it will power the board. The auto power sequencer is there with LM328. Whereas in Nano, there is only one hookup diode. Only one hookup diode is there. With that, it is being managed. So that area is being left out in Nano. With that, they have reduced the cost as well. We as a technical person, we always know that we always power the circuit with 5 volt. And the 5 volt adapters are easily available in the market. If this is the case, if I'm going to design a project, if I'm going to supply on my own with 5 volt for the board, I will always choose Nano. If I'm going to supply uncontrolled DC voltage, like ranging from 7 or 8 to 12 volt, I can go for Nano. Nano is also having a regulator inside, but that is a very weak regulator with one pull-up diode. Almost all the clones which is available from China, the regulator will not withstand not more than 9 volt to 10 volts. That means a 9 volt battery can easily operate Nano, but going beyond with an adapter, almost all of the time, the regulator will blow off. So the point here is that which one is suitable for us based on the end user's application. If I have a standard set of shields which I can directly use it, I'll go for UNO. That is very easy to assemble and I can directly go for programming it. If I'm going to design my own hardware, then Arduino Nano is best suitable for that. And apart from these two categories, there was one more board released. It is called Arduino Mini. You can see that it is there in between, a small one. This Arduino Mini was having the same set of features of UNO as well as Nano, but in a very small form factor. But it does not have a USB to serial interface. Suppose if I have a working model developed with the help of UNO or Nano, I have developed a timer switch, or I have developed a water level controller. I'm getting 8 inputs from different areas. Based on that, I'm going to control the output. So I have used the UNO and Nano to develop the board. Once the code was tested and it is working fine, that means if I'm going to put it into the end use, the USB part is sitting ideal. USB part, I'm not going to use it. I'm going to install it and I'm leaving it forever. If this is the case, I have microcontrollers available in the board. USB to serial is also available in the board, but it was not used because it is already put into use. If you are thinking that you are going to put the microcontroller into use and you already completed your programming, and it is ready for deployment. If this is the case, you can consider Arduino Mini as the board which you can use it for end use, because you can, once you have to programming it, you are putting it in the box and you are leaving it. If this is the case, Arduino Mini was released. I think somebody was not in mute. Sir, can you please mute the participant, sir? Yeah. So we have seen so far 3 boards: Uno, Nano, and Arduino Mini. Uno was released on first. Nano was on purpose, which is breadboard friendly. If we are going to put it into use, then Arduino Mini was the board. Arduino Mini was supposed to be very cost effective compared to these two. But unfortunately, current market trend, Arduino Mini was sold higher than Arduino Nano. That is a very unfortunate thing. Arduino Mini, nobody is preferring it because of the cost. It's supposed to be cost effective compared to Arduino Nano, but it was not that much cost effective. So either you can choose Uno or Nano if you are going to start building your Arduino projects. Okay. So far what we have discussed, these boards are having the capacity of programming 32K. What if my memory capacity is not enough for me to program? Say for example, you are seeing that there are. Sir, is that possible to mute, sir? Everyone?
Sir, muted, sir.
Right, sir. You are seeing that these 3 boards are having the capacity of 32K memory. You are seeing right now in the field, there are so many 3D printers available in the market. Even there are some 3D printers sold for 11K, only 11,000. So these kind of boards, if you are going into that, there will be a Arduino board inside. Arduino is actually controlling that. If I'm going to use my Arduino board for 3D printer or CNC or a major purpose, will that 32K memory enough for me? No, it will cross the boundary. If this is the case, I need a higher end programming memory boards also required for that case. So this is where Arduino Mega has come in. Arduino Mega is having 64 usable input output pins as well as 256K memory. So 256K memory is almost 8 times higher than what you are seeing it in Uno and Nano. And most of the 3D printers, if you are seeing that, the ready-made boards like 3D printers, they go for Arduino Mega. Arduino Mega is having enough reservation on 256K memory. When you are comparing the cost, it is not 8 times, it's 4 times. That means if you would like to go for a higher end programming side, or if you would like to have more input outputs, then you will go for Arduino Mega. Arduino Uno can give you maximum of 19 input outputs. Arduino Nano also can give you the same set of inputs outputs plus 2 additional ADCs that we are going to discuss later. If the 19 pins are not enough, then we'll go for Arduino Mega, which can give you up to 64 pins. Now, most of you people might have started thinking, if Arduino Mega is having this much input output, can we use this guy for industrial automation? Can we use it as a PLC? Engineers think alike. So that is where Arduino Mega has come into industrial area, and there are so many manufacturers started manufacturing PLCs based on Arduino Mega. So now you can build a Arduino PLC with the help of Arduino Mega. You have enough input output, ample input output pins. 64 pins are there. Personally, I myself designed 56 pins. I've used 32 inputs and 32 outputs. Out of 32 outputs, I've used 4 for ADC. Rest of the things I used for input and output, which was used in industry and is still running. So that means Arduino Mega is very well suitable for industrial automations and PLC replacements. Wherever you would like to replace the PLC, you can think of Arduino Mega. That is more suitable for that purpose. What is the downside? The downside is the pin configurations in the board. It is slightly complicated compared to Uno and Nano. You have to make your own shield, or you have to buy a ready-made shield, or you have to make your own PCB for it to work. Again, you can see Arduino Mega is coming with female connectors. There is no male connector available. That means if you are making a ready-made shield, then you are fine. If you are procuring a ready-made shield, you are fine. Suppose if you would like to develop your own PCB, then the Arduino Mega will go upside down because it is a female pin. You will be designing a carrier board or your own board which will have male pin. That means Arduino Mega will go upside down. You can very well set it and we can very well use it. If you have time, go through Google, just type Arduino PLC. You will be seeing so many boards available in the market which is using Arduino Mega. Okay, so far we have discussed 4 boards and what is the advantages. So we engineers sometimes play around for fun. So that is where Arduino LilyPad has come in. What is Arduino LilyPad? There was a small circular board in the center. The Arduino LilyPad is strictly not for engineers. Underline the word. Arduino LilyPad is for fancy stuff. It is the same as Arduino Mini. Arduino Mini was having a different form factor with all bigger connectors outside. So some kind of people were making a kind of a roulette watch in hand. Some people are using it for displaying outside the box with the Arduino LilyPad. It is a fancy stuff. Other than that, Arduino LilyPad is not having any other additional stuff. There is a programming connector they have kept outside. You can use it to programming it. But Arduino LilyPad is again, it is a fancy stuff. Whether it is a cost-effective thing? No, it is not a cost-effective thing. Comparing to Nano, it is costlier, and it is not recommended for normal technical programming, not normal technical programming people. It is for a fancy stuff. If you would like to do some kind of fancy stuff, you can go for Arduino LilyPad. So up to this, we are discussing 5 boards. And there was one interesting board. It is called Arduino Leonardo. Arduino Leonardo has come into picture when Atmel has released the chip, 80 mega 328 kind of chip, which has inbuilt USB controller. The Arduino Leonardo is having a chip. The chip itself is having a USB controller inside. It is called 80 mega 32U4. That chip is having a USB inbuilt. So we took that advantage because you know that, right? All Arduino boards are being used with USB to create a serial port to programming it. So if the chip is having USB, why don't we take that as an advantage? So that is where Arduino Leonardo has come into picture. They used Arduino 80 mega 328, the 80 mega 32U4 as a main chip for Arduino Leonardo, and they've extended the USB line directly to the USB port. So how do Arduino Leonardo works? When you are plugging into your computer, first it creates the USB handshaking. It automatically creates a bulk uploading endpoints as well as serial points. You can emulate whichever way the USB reacts. So you can emulate it in the USB chip itself. So they've used this chip for CDC, like serial port. Once you plugged in, it takes some time to create a USB serial port. Then after that, it starts giving you a serial access. From there, you will be able to programming it. So we go for Arduino Leonardo. The chip is having the same capacity, almost same pinouts. Only advantage is that it is having a USB inbuilt. So what is the advantage for that? Is there any technical thing it is coming to your mind? I can use Arduino Leonardo for so and so purpose. Till now, we were discussing about 5 boards, which are all having a serial interface, which you can be easily programming it. That's it. But Arduino Leonardo is having a USB interface, which is inbuilt inside the chip. Is there any advantage or something that we can plan it out? Arduino Leonardo can act like a USB peripheral. Say for example, if I have Arduino Leonardo, if I am plugging into the computer, I would like to simulate my mouse movements. Can I do that? We can very well do that because there is a HID profile available. With the HID profile, we will be able to simulate a USB keyboard, USB mouse, USB joystick, whichever USB peripheral you would like to simulate, you can simulate. Even you can create a security check with Arduino Leonardo. Arduino Leonardo with a security check, if it is being done, will unlock or your program will only run if you are plugging in a particular Arduino Leonardo inside USB. So that way you can program USB based projects with the help of Arduino Leonardo. So these are some of the variants. To be frank, these are all the earlier stage Arduino boards which is still there in the market. But Arduino has evolved much more than that. There are Wi-Fi chips, Wi-Fi chip boards already available, which is ESP8266 series. STM32 range of microcontrollers already came into the market. And there are new set of Atmel processors launched in 2020, 2021 as well. So that kind of boards are now it is coming into the market. There are so many advanced boards are available in the market. But to start with, what is Arduino and how it looks like? So these are all the boards we have covered so far. Do you have any questions on this hardware part? After that, we are moving into software part, how IDE look like, and like that we will be moving forward. So you would like to discuss anything on the hardware, we can do that now. So my understanding is that we are clear about Arduino hardware, right? So whatever you are seeing is that it is a physical appearance of this board. So how do they look like in a technical perspective? Whatever we are seeing in the earlier slide, it is the physical appearance of the board. But what is the technical spec sheet for that particular board? We are taking Arduino Nano as our case study. So this is the Arduino Nano board. If you are seeing that, you have a set of connectors in the left hand side, you have a set of connectors in the right hand side, 15 pins they have made it. On top of that, you are seeing that there is a connector called ISP. There are 6-pin connector available in the ISP, which was discussed in the first slide of our Arduino. This is the raw programming interface for this chip. This is the SPA interface, which is called in-circuit programming. So this is here. This is directly connected to this chip. If you would like to directly program this processor with the proprietary programming kind of hardware, you can use this one. But for simplicity, as of now, we are not considering this. We are considering Arduino board as a whole. We are going to connect our USB here and we are going to programming it. The programming Arduino is based on the bootloader coming inside. So if this is the case, this is the Arduino Nano's anatomy. So there are 15 pins in the left hand side. There are 15 pins in the right hand side. Each pin has its own purpose. So for microcontrollers, what kind of things are required? Normally, I will take inputs from the real world. I take either on off or I take either an analog value to read it and take action on that. So normally I take inputs from real world. For that, I need inputs and outputs from the microcontrollers. So almost all the pins which is coming outside the nano board are usable as input and outputs. If you are seeing that, starts from the left hand side, first 2 pins can be used as input and output, but can it only be used as input and output? It can be used for other functions as well. So that is where these boxes are representing it. In this configuration, You are seeing a violet color boxes, which is there in the left hand side and right hand side. The left hand side, what you are seeing is that numbering starts from 0, 1, 2, 3, 4, 5, 6 up to 13. It is there. Then 14, 15, 16 up to 19. So these are all the numbers which is being referred by Arduino. That means I no need to remember the pin number or port number of this microcontroller. For example, if you would like to refer a pin number 2, I would like to switch on LED on and off in pin number 2. I can simply use the number 2 to refer this pin to switch an LED which is connected to this pin to on and off. But what if I'm going to directly programming it with the help of other kind of programming languages? If I'm going to use the other languages, I need to find out which port the pin is residing. The port is residing in PD2. In the PD2, that means port D number 2 is being used to control this pin. If I'm going to use other languages like raw C, C++ programming languages like WinAVR, I have to know the port and I have this port and I have to set this number for input and output. So this is where Arduino simplifies our usability of the hardware. I can simply refer number 2 and I can start programming this pin for input or output. So you can see that this is the advantage of using Arduino. You can straight away refer these numbers and you can use it. We are going to see some kind of example programs in the upcoming slides, how easy for referring these pins. But what you are seeing is that there are Arduino pin numbers, but it has additional functions as well attached to each pin. If you are taking from the left hand side, starts from the first pin. The first 2 pins are used for serial communications predominantly. First pin is for transmitting and second pin is for receiving. And these 2 pins are referred in Arduino as 0 and 1 as well as serial port. So Arduino can use these 2 pins for sending serial information with the help of TX/RX, or it can control these pins with 0 and 1. We refer it. Now the basic question is that we know that we are going to use USB to program the microcontroller, right? The USB is going to create a serial port for us. Where exactly the serial port is connected to this chip? The USB chip in the bottom side of the board, which is creating a COM port for us in Windows. That COM port should be connected to this processor so that I can use this bootloader to upload my program. So this bottom USB to serial, where exactly it is getting connected? The USB to serial, one side it is connected to USB, other side where it is getting connected? Other side it is getting connected to these 2 pins. These are all the TX and RX, which is the serial interface for this chip. So this is being connected here. That means the chip is already holding TX and RX here. If you want to use the TX, you can very well use it. RX, it is a bit tricky because the chip is already overloading this pin. If you understand this, keep it. If you don't understand this, we'll have the discussion in the FAQ part. So this is our anatomy. In this anatomy, we are saying that we can use this Arduino Nano up to 10 input-output digital pins directly. Apart from that, we have 5 ADCs straight away available. What is ADC? Analog to digital converters. That means these pins can be used as input-outputs as well as analog pins. I can give a voltage of 0 to 5 volt in this pin. I can measure what is the voltage which is coming inside the pin. These are all very useful for interfacing sensors like temperature sensor and other analog sensors, which can be connected here and we can read the signals. So as you can see, we have 13 input-output digital pins, which is specifically used for digital purpose. Apart from that, we have 5 6 ADC pins straight away available, ADC 0 to ADC 5, and Nano is exposing another 2 ADCs as well, ADC 6 and 7. That means Nano can have 8 ADC ports, but ADC 6 and 7 can only be used for ADC, not for digital purpose. So that is where box is missing here. Arduino Nano, all 8 ADC ports can be used for taking analog inputs, and up to 6 pins can be used as a input output as well. In that, there are 2 ports which is used for I2C communication. I2C communications are 2-bus communications, which are very useful for controlling multiple devices in the same line. So these portions we will be discussing when we are going for interfacing. So on the whole, what we are seeing is that an Arduino can have, basic Arduino can have maximum of 19 input output digital pins, or it can have 13 input output digital pins and 8 ADC channels. So these are all the mandatory things which we would like to keep it in mind. Apart from that, other pins are supportive pins, like 2 pins are used for ground, and 1 is for 5-volt input, and 1 is for 3.3-volt output. And there is a V-in pin as well, which is connected to a regulator inside, so that we can pump in maximum of 9-volt. 12-volt normally I will not recommend, because 12-volt regulators which is there from China are not withstanding for 12-volt. Normally V-in can go up to 9-volt, that is safer for Nano. So these are all the pin configurations for a Nano. So why we are seeing this? We are going to do some kind of experiments with Nano only. So understanding the pins are very much required here. So far, you have any doubt? You would like to discuss anything on this Nano pin out? Shall we move forward? Okay. For this session, we are taking Arduino Nano as our experimental setup, and we are going to do some kind of programming languages. So far, what we have seen how the hardware looks like and what are all the facilities available in the Arduino Nano. So some of these features we have seen, some of the features we have not explored. There are so many tricks already there inside its sleeve. We are going to explore slowly in upcoming sessions. Okay. Now we are going to see what is Arduino IDE. So are you able to see my screen? Arduino IDE screen?
Yes, sir.
Okay, great. So this is the screen. This is the IDE. What is IDE? What is the expansion of IDE? Integrated Developing Environment. It is only a technical term, which is a collective term. Almost all the front-end GUI for programming is called IDE, and here also we are calling it as an IDE. It is nothing to do with specific to Arduino. The software front-end looks like this. Arduino IDE. So the Arduino IDE is a very simple interface. The Arduino IDE interface is used to write the program, compile it, and send the program to the Arduino hardware, so that the Arduino hardware can function as we program it. The Arduino IDE is written in Java, and I don't know why still they are retaining it in Java. Still it is being retained in Java itself. The current version of Arduino IDE is 1.8.16, which is also came a long way. The basic idea here is that we should have a front-end GUI or IDE where we will be able to write our program. Then we will compile it. Once it is being compiled, it has to send to the Arduino hardware so that Arduino hardware can function properly. So this is the basic need for the IDE. So the IDE is having a very simple interface like file, edit, sketch, tool, help, a basic set of tools. We are going to walk through all these things first. Before going into that, what is required here now? We have IDE installed. The IDE is there inside. So what are all the specific parameters required? First, the IDE should know what hardware interface we are going to interface with this IDE. What kind of hardware we are going to connect it. We already seen, right? Arduino Uno, Nano, Mega, Mini, all these stuffs. So first thing first, the IDE should know what hardware we are going to interface it. For that, we are going to the tools menu. In the tools menu, we'll be having a interface called board. If you go to the board, there are so many boards available. Normally, if you are installing a fresh set of Arduino tools, these are all the boards by default it is available. As you can see, so far actually we have seen only 5 or 6 boards, but you can see that here there are so many boards available. This is not the end, this is a very beginning one, but we have so much of other boards available there. So here you can see that if you go to the tools, boards, you will be seeing the list of boards available, where you have Arduino Uno, which already we have discussed, which is available. Arduino Nano, which is also available. Arduino Mega, which is also available. Arduino Leonardo, we have already seen that, which is also available. So these are all the boards you can straight away. For our test purpose, we already concluded that we are going to use Arduino Nano. So I'm going to choose Arduino Nano. Now I'm already configured my IDE to program Arduino Nano. You can see that. In that Arduino Nano, what kind of chip is being used? There are 3 chips. Earlier it was released in the market. The first generation boards were carrying Arduino 80MEGA328 as well as 80MEGA168. 80MEGA328 is having a 32K memory. 80MEGA168 is having only 16K memory. Over a period of time, 80MEGA168 was phased out. It is very rare to find 80MEGA168 in the market. The reason is that it is not a cost-effective solution. It is a cost-effective solution. So we used 80MEGA328 by default. 80MEGA168 is slowly phased out. 80MEGA328 is only available. After that, in 2019, a new set of chip were 80MEGA328 PB, which was very good, but still it was not picked up. Here you are seeing that Arduino 80MEGA328, you have 2 options. So one is 80MEGA328 and old bootloader. Why there was 2 entries? I am choosing board as Arduino Nano. In the Arduino Nano, what kind of processor I am going to use it? There are 2 entries here, 80MEGA328P and 80MEGA328P old bootloader. Because the reason is that Arduino was manufactured with huge quantities from 2011. There are so many boards were manufactured. There are so many boards were available in the market. About 2015 or 16, hundreds and millions of boards already manufactured and it is there in the market. That boards carries old bootloader. If suppose you have purchased some board which was manufactured in 2016 and 17, that board might have old bootloader. That means the new bootloader program will not work. So that is the reason they have given 2 options. If you have purchased a new board, it might have new bootloader. If it is a very old board, you can use old bootloader to use this one. This is going to be a headache, right? This is the headache. We have to live with it when we are going for open source programs. Open source programs are being developed by all the engineers who are all available for developing. So many engineers are working in some other field. In their free time, they'll be developing programs and they'll upload it. Most of the engineers, they'll work for some time and they'll not have enough time to work for further updates. So that is the reason when we are adopting open source programs for any other purpose, we should always see that the development is up to date. If the open source development is not up to date, then this kind of anomalies will come. Since it is a hardware, it is already flooded in the market. We cannot change its bootloader. So they have given an option for choosing a old bootloader. So I'm assuming that we are having a new board. So I'm choosing Nano and processor as Arduino 80 Mega 328P. So this is the only two configurations required if you are using a normal Arduino board. That means this IDE now it knows that it is going to program Arduino Nano, which has the chip 80 Mega 328. So only these two are required for programming it. When coming into the sketch, how do we programming it? In the programming area, you are seeing that there are two functions. One is called setup, another one is called loop. Whenever you are going to the file, new program, every time you create a new program, automatically these two functions will be populated in that. Why is that? Because Arduino's programming structure relying on only these two functions. First function is for setting up the Arduino. Second function is that recursive run a instruction set. So this is the reason actually they've adopted processing language. If you people already have exposure for processing language, you will already know that it is also having the same structure. If you are not exposed to processing language, please take some time, download processing language from internet. It is again free, like Arduino. It is an open source. You can download and you can program for Windows as well with that processing language. If you are downloading processing language and if you are having Arduino GUI both, you will be able to see the similarities. The similarity is that programming structure has only two functions. One function is for setting up, another one is for recurring. What is setting up? The setup loop will run only once. Once you are programming something here in this function and you are uploading into the microcontroller, whatever code you put it within the setup function, it will run only once. After that, it will go to the main loop. The main loop will recursively run. How far loop will run? Approximately, it is going to run around 100 kHz speed. But 100 kHz is enough for me to run. The processor itself is having a processing speed of 16 megahertz. That means if I have 4 cycle instruction set, I can run the processor at least 4 megahertz speed. But if I'm doing some kind of codes within this loop runs around 100 kHz. That means it is a bottleneck, right? So this is where we engineers will take over from here. Once we are coming into the main loop, either we can allow the main loop to control the whole process, or from here on, we can make our own function. Like I'm creating my own function, my function. I straight away call this my function. And here I will write my function to take over the control. As you can see, the setup will run only once. The loop will recursively run. If the main loop speed is not enough, or I would like to do something else, I can redirect my code to my own function. Once coming into the loop, this function will be called, and I'm going to my own functions where I can run my code as fast as possible. So this is the flexibility of Arduino. Either I can simply use its inbuilt functions with a minimal set of hardwares, with a minimal set of pain in programming it, or I can use my own set of functions to solve my complex problems. So this is the flexibility of it. So as far as Arduino IDE is concerned, you have IDE. The IDE is specifically used to program the hardware, and we are going to set the hardware, which hardware we are going to use it. Then we are straight away going into the sketch. In Arduino, programs are called sketches. This is the nomenclature they've given, so we are following it up. That's it. Otherwise, there is a technicality behind it. In the Arduino sketch, normally you will be having two functions. One function is called setup, which will run only once. Another set of function called loop, which will run continuously. So only these two functions will be available in Arduino. As simple as that. So what is the purpose of setup? It is going to run only once, right? That means if I'm going to define what is the input which I would like to use, what is the output which I would like to use, I can define it here. The reason is that for Arduino, if I have a pin number 2 that I would like to use it for output, I'm going to declare it only once, right? In a program, only once if I'm saying that this pin is used for output, that's enough. That means that kind of codes will be residing in setup. A code which is going to run only once will be residing in setup. Once the setup loop is over, continuously changing codes will be there inside the loop. This is the Arduino basic IDE, but I'll leave it to you for some other things to explore. If we have time, we'll discuss that. I think already we are crossing about 1.5 hours now. Sir, how much time do we have, sir? If we have time, we'll go into theory. Otherwise, we'll go into some practical mode. Okay. Do you have any doubts in this Arduino front-end IDE? Should we discuss, or we'll go for some practical applications? Am I audible to everyone?
As time is less, we'll go with the practical applications only, sir.
Right. Right. Okay. The reason is that I'm saying that most of you people are much more higher standard. So I don't think I should go walking through all this new open command examples. I think I strongly believe nothing is required here. So these are all mostly self-explanatory. Some tricks are there, like preferences. If you are going there, you will be defining some kind of URL to develop, download your libraries and other stuff. That we will later will take care if we are going to interface sensors. Otherwise, not much here. Only tools where board manager and process are mandatory. Then creating sketch is the mandatory thing. Apart from that, there are standard 5 buttons available in the menu. First one is for compile. If I click it, it will ask to save my project. So I'm just saving example 1. Once I'm clicking compile, you can see that it is compiling. The code has nothing. There is one setup empty loop. There is one setup loop, setup function, and there is a empty loop. Nothing is there. I have just compiled it. How do they compile it? Where exactly it has done? Whatever code I've given here, The code was targeted to Arduino Nano and targeted to the processor 80MEGA328. With this target, the empty code was compiled and it has created a binary for this board. This binary can be uploaded to the board to see the function. The first one is to compile it, second one is to upload. As you can see, there is a strange output. I've given nothing. Nothing is there in setup, nothing is there in loop, but still the sketch is using 444 bytes, 1% of my memory. Nothing was there, but still it is using 1% of my memory. This was the loophole in Arduino. This was the required loophole for Arduino. There are some specific set of frameworks which is required for Arduino to set up, like adding pin configuration for a particular board. We have to add the pin configuration so that Arduino IDE can understand which pin should I use it for what purpose. So there are basic set of functions which is always going inside, which is occupying this minimal set of programming space. Of course, still this can be minimized. We have some other tricks to minimize it, but this is out of scope as of now. What you are seeing is that an empty sketch still occupies 1% of programming memory. Since there is no variables defined, there is no RAM space allocated for this code. So this is what we are seeing it here. So it has simply given the output, no technical information available. I would like to see what exactly happening behind the scene. If I do the compilation, what exactly happening in the backside. If you'd like to see, if you'd like to see what exactly happening behind that, just go to the file menu, preferences, show verbose output during compilation. Just give OK, and now compile it. If you are compiling it, each and every stage of compiling process, you can see that in the screen. Just for curiosity, just we'll go through that compiling messages quickly. If you like to have more deep discussions, we'll have it later. Okay. What exactly it is doing? I have given a target. What target the code should run? And what is the processor it has to use? These two things I've given, and I've given an empty sketch called example1.nano. What exactly it is doing? It is taking Arduino builder tool to take some basic parameters for hardwares and libraries, and after that, since the configuration actually I've used for Nano, it is targeting the compilation towards Nano and using the core. The core is the basic functions to control input outputs. It is taking the core functions which is targeting to the Nano and start compiling it with the help of AVR GCC+. The reason why I've given this one is that it is using the AVR GCC+ compiler for compiling the code. Now the mystery is revealed, right? I have a front-end GUI, I have a hardware, and I am trying to compile it. What compiler it is using? The compiler being used for this processor is for AVR GCC+, AVR G++. Those who worked with Linux very well know that GCC is the very famous tool chain for programming it, right? GCC and GCC++. GCC is for C and G++ for C++ programming. This is an open source programming tool chain which is available in Linux that was ported to program Atmel process. AVR tool chain is ported from GCC, which is targeting towards our Atmel process. So when you are doing a compilation here, what it does, it takes the input Nano as the target and takes the core file from Arduino folder and it is using the AVR GCC to compile and create the binary for the board to upload it. What it does, first it takes the INO file, make it as a C file, and creating an object file. From there, it creating binary file. So this is the normal set of compilation process for GCC, and the same set of compilation process is going here. So for simplicity, we are going to remove the verbose again. Once you have removed it, you will not see the verbose output, only the result output you are going to see it. So this is only an empty sketch which we have run it. So now what we are going to see, we are going to walk through a code, how the programming is happening inside the Arduino IDE and how it is being uploaded to the Arduino. Now we are living in 2021. Should we need a hardware to you people are experienced much in most of the fields. When we are doing a testing for a hardware, are we doing hardware testing every time? Are we are doing some kind of simulation? In 2021, we have so many tools available for simulating Arduino. There are so many open sources. If you would like to go for a costlier, very perfect one, you can go for Protos Simulus, which is very costly. If you'd like to go for open source, there are so many things available, Tinkercad, different kind of sets of tools available. Normally, I prefer the quick setup. Normally, I prefer Simul IDE. You can note down this one. If you have free time, you can download it and you can run it in your PC as well. It is called Simul IDE. The Simul IDE is being used to simulate Arduino in your computer without any physical hardware. As you can see, this is our Arduino IDE, where we will be normally using it to program our programs. And if you'd like to stimulate something, you can use Arduino Simul IDE, which can be used to simulate it. I'm just showing some examples on Arduino Simul IDE. I've taken Uno as my this thing. Are you able to see my screen?
Yes, sir.
Yes, sir.
Okay. So what you are seeing is that instead of a real world hardware, we are going to simulate and see how the Arduino is functioning. Already we have seen that this is the Uno board. Uno board. Uno board is having a set of edge connectors available in both sides. And we know that there are input output pins starts from 0 to 13. And we know that we have analog pins A0 to A5. There are inputs available. So I can use any of the digital input output pin to program and simulate something. So in our first program, as usual, like a hello world program, normally all programs starts with the LED blink. We are going to blink an LED in the Arduino Uno. So if you are going to blink an LED, how will it run? Once we are programming it, the Arduino Uno should run like this. There is an inbuilt LED available in the board that will also blink. If I connect external LED to this pin, that LED also will blink. So what we are going to do, this is the experiment we are going to do. In this experiment, we are going to analyze the code as well, how the IDE is taking the instructions and processing it. As you can see, we are connecting an LED to the pin number 13. So when we are going to the Arduino IDE, we have two functions. One is called setup function, another one is called loop function. We know that setup function will run only once. In setup function, we are going to define some kind of instructions which is going to run only once. So here, what is the function it is going to run only once? The definition of pins. I'm going to use pin number 13 as output because I am connecting LED, so that the pin should be defined as output, and this code will run only once. If this is the case, this instruction I will put it inside my setup. So what is the function for setting my pin as output in Arduino? The function code is pin mode, open bracket. What is the pin I would like to use? Here I used some kind of alien name that we will be discussing later. To be frank, in the pin mode function, I'm going to use pin number 13, and the pin number 13 is going to be used as output. The output is in caps. This is the keyword. Either I can use as output or I can use it as 1, whichever way. So here we used as output. So what we have done in the setup code, we are defining pin 13 as output, and this code is going to run only once. So I'm keeping it in setup. So I've defined the 13 as output. Now what we are going to do, I blink this LED. How do I blink it? First, I need to make the 13 pin as high so that LED can on, and I will give some kind of delay so that I can see that LED is working. After a delay, I will make the 13 pin low so that LED is off. Then again, I will give a delay. Again, the code is going to be repeated and again and again. If I am doing that, LED will blink. Correct? If this is the case, first instruction is for making the 13 pin high. To make the pin high, the function is called digital write. The digital write will again take two inputs. One is what is the pin number which I'm going to change, pin number, and what I'm going to do, I'm going to make the pin high. The high is the keyword which is given as in caps letters. Either I know the keyword, I can type it as high, or I can make it as 1. If I make it as 1 also, it will work. Why we are doing this kind of confusion? The reason is that if I'm making it as high, it is very readable. The code is very readable. Next time when I'm going through the code, I know that I'm going to make it as high. If 1 or 0, technical people can understand. Some non-technical people may not be able to understand. So that is the reason the keywords are there. Keywords are actually replaced with numerical values when we are compiling it. So what we are doing it, first we are making the output as high with the help of digital write. Then after that, we know that we are giving some delay. The function is called delay. The delay function will take input as milliseconds. Delay function will take it as milliseconds. So once LED is on, I would like to keep the LED on for 1 second. That means 1000 milliseconds. So I'm giving delay as 1000 milliseconds. Once 1 second is over, again I am making the pin as low with the help of digital write function. Then I am giving 1 second delay, and that's it. These 4 lines of codes were there inside the main loop. That means these 4 lines of codes are sequentially executed, and it is repeated again and again and again. This code will run only once. That means I'm setting the 13th pin as output only once. After that, I'm going into the loop where I'm changing the status of the pin with the help of 4 lines. These 4 lines, one by one, it will get executed. First, it will make the 13th pin high. Then it will give a delay of 1 second. Then 13th pin low, giving delay of 1 second. Once it is over, it is jump back to the first port and it is getting repeated. So that is the reason once it is being programmed and it is being simulated, the 13th pin is going high 1 second, going low 1 second, and it is being repeated. Just to show it in the Arduino IDE. The code will look like this. A setup function only once and loop function forever. Now we are going to again set this compilation verbose mode and we do the compilation. We'll see how it is going. It is cross compiling all these things. This time the sketch is using 3% of your memory. Earlier we have a blank sketch which was using 1% of your memory, and now we have added some instructions which is using 3% of your memory. So that now you can see that up to 30K of memory can be directly utilized for programming your microcontroller. This is a simple blink program, so it is only occupying 3%, but you can go up to 30K memory of your microcontroller. As you know, ATmega 328 is having a memory capacity of how much? 32 kilobytes, right? But once you are compiling that, IDE says that it has only 30K of memory. Why? You have any idea? Anyone? As you know, the microcontroller is having
maximum memory is 32 KB.
Yeah, 32 KB is the maximum. But when you're doing the compilation, it says that the maximum is 30.72.
Sir, the rest amount is for its keywords or some functions like that, which is already included in that memory part.
No, that is not the correct answer.
Okay, sir.
We as engineers always miss this kind of small trivial matters always. The reason is that when we are discussing about the Arduino in the first slide, we were talking about bootloader. There was a small bootloader which is being programmed inside the microcontroller so that you can serially programming it. The bootloader portion is residing in the bottom side of your memory. So that is why the bootloader portion was being taken out here. So the bootloader itself is taking about 1.3K of memory there. Normally 2K memory we will be reserving it for bootloader. That 2K memory we cannot use it for our programming purpose. Arduino's one of the downside is that the bootloader is being reserved only for programming it. Out of 32K memory, 2K of the memory in the bottom side of the programming language which is used for bootloader. That is the bootloader actually taking the instruction from the IDE to program the chip. So that portion cannot be used for programming it. So the IDE will restrict your code up to 30.7. This will vary board to board. If you are taking 80 mega, it will take 4K of memory, so on, so on, so on. But whether this is changeable, it is changeable. If we are going to technically work, at times, normally when I'm doing programming for 80 mega 8, which is 8K memory, normally I touch 99% of its memory. During the time, what I will do, I will remove the bootloader. I will directly program the IC with the help of programmer. If that is the case, I can utilize full memory. But when we are using it with the Arduino IDE with bootloader, 2K memory will be reserved for that. Rest of the memory places are available for your programming it. So this is the significance of our compiling output. So every time you can see that how much is the global variable used here. Global variable used are 9 bytes, which is 0% of your 2K memory. You used very, very less thing for the global memory. So this is our first Blink program. If you go to the file, examples, basics, there are so many examples available here. Already inbuilt examples are available here. How to connect it with Arduino, it is we can see that. You can use the Simul IDE to simulate most of these examples. Without any real-time hardware, you will be able to simulate this code and you can see how it is performing. When you are going to the examples, basics, and you can see that there is a ready-made Blink program available in this sketch. If you open it, open it.
May I ask you a question, sir?
Yeah, please.
Sir, actually, I was trying to do a project with 2 Bluetooth modules.
Okay.
But during this scenario, I can't go to the college. So that is why, if I want to simulate in this software, so is it possible?
Very much possible.
Using 2 different Arduino and using 2 different Bluetooth modules, is it possible, sir?
Possible. Very much possible.
Okay, sir. Okay, thank you.
Sir. It is possible. If you would like to test it, you can use a Tinkercad as well. Tinkercad is a web-based GUI, online web-based GUI. Arduino Simul IDE is one of the things. If you would like to use it with the pure technical perspective, you can go for Atmel AVR Studio as well, Microchip Studio as well. That is the official software which is coming from the vendor, which is slightly tedious to understand its interfaces, but that will work like a real microcontroller hardware with the registry setup. But as of now, Simul IDE is evolving. As of now, Simul IDE is still evolving. There are small few bugs are there, but simulating is not at all a problem for your case as well. If you would like to simulate a serial port, it is very much possible. I think we have completed the walkthrough of IDE. So if you would like to discuss anything about IDE, let us do it now. Otherwise, we'll keep 15 to 20 minutes as our FAQ, where we can discuss whatever points we would like to discuss. So this is the basic interface for Arduino. What we are seeing that we have seen that Arduino is an ecosystem. It is a hardware and software mated. We have a set of hardware which is available, and we are configuring that hardware to the Arduino IDE, and from there we will be able to do a programming directly. So that is what we have seen. In the IDE side, if you have any doubts, we'll discuss now, or we'll keep another 10 minutes for FAQ. So where you can discuss anything you want.
Sir, someone posted a question in the chat box, sir, how to give termination condition.
How to give a termination condition, okay. Say for example, this is the Arduino sketch. This function will run only once, but this function will run forever, right? That means if I put a code here, it will run forever. But for me, I would like to run this loop only for 10 times. After that, the loop should not run. Is that what the termination condition you require? I take an integer for CNT, just a name I'm just giving, and the CNT value will be 0 when setup loop is running. Setup loop only once it is running, so I'm just initializing this variable. In the main loop, I'm just incrementing the counter. One time if this instructions are running, I just increase the counter. If CNT is greater than or equal to 10, I just keep the loop logged. What we are doing, we are creating a small variable. The variable will increment continuously. Once the variable is equal to 10 or greater than 10, the loop will freeze. After that, the loop will not run. Once again. I think there is some kind of issue here for me. I just compile it. As you can see, that blink was running for 10 times. After that, it got freezed. Is that what is required? If you would like to have a time-based, if you would like to have a time-based event, that is also possible. In the blink sketch, you can see that there is a counter actually we put in. Once the counter is reaching to the particular value, you can freeze the loop. If you would like to have a time-based, thing, you can create a time with the help of millis. Millis will run once you start the microcontroller. You can use this millis to find out whether the required time has come. Sorry, I need to define as global. So you can see that the second program actually it has run only for 4 seconds. So either you can use your count to freeze the loop, or even you can use time to freeze the loop. Yeah.
Okay, thank you, sir. Shivakumar, sir.
Yes, sir.
Participants, if you have any queries, you can raise, or otherwise we'll wind up the session. Tomorrow morning, sir is going to handle with the different sensors, practical hands, give a demonstration in the tomorrow morning session.
Sir, somebody was asking for 2 serial ports.
Yes.
So you can elaborate it. If it is required, we can simulate it tomorrow. The same setup.
Yes, sir.
Thank
Tomorrow
you.
we can.
Thank you very much.
You'd like to have 2 serial ports, right?
Yes, sir. Actually, I just want to know in one screen 2 different Bluetooth modules with 2 different Arduinos. How will it work?
Okay. We would like to stimulate 2 different Arduinos. One Arduino will send information from Bluetooth to another Arduino with Bluetooth. One is sending, another one is receiving. So we need to display it, right?
Yes, sir.
Yeah. Okay.
Thank you
We'll
very
do that. We'll do that. We'll try to make the setup tomorrow. So when we are doing this testing.
Thank you very much, sir.
Yeah. Thank you.
Thank you, Shivakumar sir, for giving a wonderful introduction to Arduino IDE and some basic programming on using Arduino. And on behalf of our institution and the participant, I will thank you for presented a wonderful session, sir. Thank you, sir.
Yes, sir. It's very energetic participants today, sir. Thank you so much for this energetic participants for this session.
Yes, sir. Many want to have a like this practical application oriented session only, sir. So tomorrow you plan accordingly and deliver, sir.
Sure, sir. Thank you, sir.
Okay, thank you. Thank you, participants, and kindly join at 2:15 for the afternoon session on Raspberry Pi. So and send a feedback form after this session. And thank you once again, sir. Thank you very much.